Test, test, test. Test, test, test. No, because I don't think she's connected. Yeah, could she call? Check. This is a test. This is a test. This is a test. Yeah. Okay.
Good morning. If I could have everyone have a seat, we're going to start. My name is Erin Rampersad. I'm actually the coordinator down here in the West Atrium. I'm just going to do some brief housekeeping just in case of an emergency. I will direct you guys. We're going to file out the way you came in the New Jersey Avenue entrance. Please turn off your cell phones or put them on vibrate. The restrooms are located on both sides of the corridors in front of me and both in the back of me. If you need to go, please put all your trash in the trash cans. And we'll start your event momentarily.
All right, thank you, Erin. Good morning, everyone. My name is Alan Mayberry. I'm Acting Associate Administrator for Pipeline Safety in the Office of Pipeline Safety at PHMSA. It's a pleasure to welcome you today to this important conference on LNG that we'll have for 2 days, today and tomorrow. This meeting is being webcast as well, so welcome to our webcast participants. And I'll go through a couple of introductory housekeeping type notes that kind of follow on to what Erin mentioned to you, and then get into some background slides before we start with our first panel. But we do, as you've seen by the agenda, have a very action-packed agenda, so we'll try to proceed with efficiency. First off, let me introduce some of the PHMSA staff here today. If you have any questions over the course of the next 2 days, see any one of these staff to get your questions answered if you need help navigating where to go. So first off, if PHMSA employees, if you could kind of raise your hands here. We've got Joe here, Max, Julie Halliday, who is responsible for this, and we thank immensely for all of her good work here. So sprinkled around, we have PHMSA people here who can answer any questions you may have as we go forward. We don't always have meetings here. I'll remind you, this is a secure federal building, so there's controlled access coming in and leaving. At least you don't have to take your shoes off when you go through the metal detector. I think that's kind of a plus, but if you do leave, you have to go back through security at lunchtime. I think you've already been told the restrooms are back here to my right on the left, down the corridor that you had when you came through. And then there's snacks and there's a coffee bar here beyond the curtains to the left, my left over here. Anyway, we are looking forward to a constructive meeting. It's a highly relevant topic. I think there's a lot of, as I was saying to someone earlier, a lot of pent-up demand on this topic, especially as far as federal policy making and the need to update regulations. We encourage you to participate and focus on solutions. Certainly there are a lot of viewpoints. We do want to maintain civility in this meeting, so please, we can express differences, but let's maintain an air of civility and respect for one another. We do these workshops. They're very important to us for input from the public, the stakeholder community, which would include operators, service providers, engineers, consultants, the public, people who live nearby to the facilities that are being proposed, they're constructed, and to hear various inputs from the stakeholders, and also to gather input as we proceed down the road of going to rulemaking, which we'll get into over the course of the next 2 days, give you a flavor of what to expect as far as what we're doing on the national policy front. There obviously is no official action taken during this meeting. This meeting is strictly for input, and we're establishing a public record on the topic. And the input used from this, as well as input that we receive from comments that are posted on our public docket, will be obviously collected, and we'll use that as input as we proceed down the road toward rulemaking. But we'll give you an idea of what to expect as we go forward on that. I think with that, let me get into what I plan to do before we start with the first panel, is give you sort of a lead in with a background on the Office of Pipeline Safety and the topic at hand, and then we'll move to the first panel. But again, welcome. I appreciate many of you who travel far to be here, some from overseas. I hear one person just came here from Singapore, so a pleasure to have people from all over the world to discuss this important topic today. And then of course you on the webcast. And by the way, speaking of webcasts, I would be remiss, there's a way for you to submit questions, and there'll be an opportunity for all for questions and answers. And the instructions are on the web page, the phmsa.dot.gov, but questions are submitted to pipelineforum@dot.gov. That's probably the most convenient way to get your questions answered, or to get your questions to us, and then we'll present them to the panel. This webcast also is being recorded and will be available on YouTube. If you go to our website, the link for that will be available as well, as are the presentations that you'll see. In fact, I think the presentations may already be uploaded, to my understanding today. But anyway, without further ado, let me just get into some introductory about PHMSA, the Office of Pipeline Safety. We are one of 11 operating modes within the U.S. Department of Transportation. We work alongside our sister agencies, the Maritime Administration, the Federal Aviation Administration, and others, as you see on this slide here. PHMSA has two parts. We have the Office of Pipeline Safety, which I represent, and our staff here today represent, and then we also have the Office of Hazardous Materials Safety. Both of us have a connection with LNG, by the way, and we also have some discussions or presentations from our Office of Hazardous Materials Safety over the course of this conference. We have a new and retooled mission and vision statement. It's a modification of our prior mission statement, actually, and also our vision as well. But our mission is to protect people and the environment by advancing the safe transportation of energy and other hazardous materials that are essential to our daily lives. You know, our focus there, I guess, on advancing, which means we regulate, we implement policies, we enforce a variety of methods that we advance safety. We promote safety. We are a safety organization. That is our focus, is pipeline safety, and in this case, liquefied natural gas safety. I think it's probably fitting to say, or that related to our vision, that we do strive to be the most innovative transportation safety organization in the world. It's really something that we our target, and certainly with LNG, probably more so than many of the areas we deal with, and we're doing a lot of work related to our pipeline regulations, but certainly with LNG, it's in pretty good need of advancing and being more innovative and moving beyond, the 20th century more into the 21st century, and dealing with the issue of regulatory lag. This is a slide just showing what we regulate. As you can see, there's almost 2.7 million miles of pipeline out there, but then also related to liquefied natural gas. 115 plants, which comprise 205 tanks and 83 operators out there. An overview of the pipeline system. This only represents transmission and hazardous liquid systems. Liquid is red and transmission is blue. And that's about 600,000 miles of the 2.6 million miles. The balance, about 2.1 million, is distribution pipelines. Related to LNG, you can see this map indicating where the LNG facilities are located. The green dots there or green circles rather, are peak shaving plants, sort of the traditional use for liquefied natural gas, but we're seeing this map, the population of coastal facilities for export, and then also in onshore facilities for small scale are gradually increasing. That's changing the landscape. Some of our responsibilities is kind of plain vanilla for many of you who deal with us day to day, but we do publish three regulations of note, really. I mean, there are others that we also have, but Part 192, that's well known as our gas pipeline safety regulations. Part 193, the LNG regulations, and then Part 195 for hazardous liquid. And then we perform comprehensive inspections against these regulations, and then we monitor and enforce compliance. And there are a number of tools at our disposal to do that. We oversee the industry through, I'll get to that in a moment, but our regional offices and about 150 and growing inspection staff nationwide that cover all 50 states and Puerto Rico. Our underlying principles is it's incumbent upon the operator of whether it's an LNG facility or a pipeline to know and understand their system and know and understand the risks of operating the systems, the threats involved. We do establish the federal minimum standard for regulations, but we're not satisfied. Complying with the regulations won't necessarily ensure safety all the time. In many cases, the operator may need to go beyond the minimum standards, so we strive to affect operator performance beyond the minimum standard. The focus is on performance. In a nutshell, the operator needs to do what it takes to keep the tiger in the tank, so to speak. Okay, now here's where we're located, nationwide through 5 regional offices, and then we have a couple of district offices, one in Alaska and one in Ontario, California. Then we have our training facility in Oklahoma City. As I was mentioning earlier, our focus here today and why we put these workshops on is to listen and to gather input and to bring the greatest minds available to bear on technical topics. The focus is highly technical, and we do want to gather input that will help guide us as we move forward. And of course, we're looking at obviously new technology, best practices, I would say, as well, process safety management. And then I think it's been pretty well documented, but perhaps we'll hear a bit over the next 2 days. What are some of the challenges for data regulations? Certainly I could go through a number of them, and we've heard from many of our stakeholders related to that. We'll also, in the agenda we have covered as far as how we communicate what's happened as far as incidents. Fortunately, LNG is a very safe way to store natural gas and for usage, but we want to keep it that way. And what are some lessons we can learn from incidents that have happened out there? And then, of course, we'll communicate our plan to update Part 193, which we've developed. Basically, what is regulated under 193? If an LNG plant is connected to a Part 192 pipeline, it generally is connected, or it's generally regulated under Part 193. There are some exceptions to that, but generally speaking, if it's connected to a pipeline that's regulated by us, it will be regulated by us. The LNG facility will also be regulated by us. Now, there's some facilities that are not regulated by us that handle LNG, and these typically are depots or facilities that receive their LNG by other than a pipeline that's regulated by us. It'd be typically a tanker truck, or it could be by a marine vessel. And that's where the connection within our office with the hazardous material safety side of the house, we connect with them who do deal with movement of product over the road for facilities such as the ones that are illustrated here. As you know, LNG, the regulations were first promulgated back in the 70s for Part 193, and they typically applied to peak shaving plants where you had a very large tank, very large piece of property, and the various components that are identified here. We've moved beyond that from peak shaving to just a few years ago. In fact, when I first came to PHMSA, import was the name of the game, and we were going like gangbusters to deal with import. And oh my, how that has changed just in a few years, short years. Now we're looking to export. So we have these facilities that are in service, in the early stages of being in service, and then several proposed for export facilities. And then now we're saying, as far as applications for all this vast resource that we have of natural gas, small-scale facilities that aren't necessarily regulated by FERC. They're intrastate facilities, and those are on our radar as far as how do we develop regulations to apply to small-scale facilities, especially ones that are being proposed in industrial parks and the like. Whereas the traditional design for an LNG plant involved large pieces of property. Of course, here are some examples of the small-scale utilization for transportation, motor fuels, and also for marine fuel as well. We do coordinate with multiple agencies. Certainly, small-scale LNG presents an opportunity, a challenge for coordination among multiple stakeholders that are out there, and those are listed here. We work closely with the state and local related to the intrastate facilities and provide help and guidance to our state partners. As far as what our plan is, overall plan, and we'll flesh this out a bit more over the course of the next couple of days, and certainly in the Q&A, I'm sure there'll be an opportunity to ask about further details about this, but we do have plans to update Part 192. Of course, one of the first steps was to hold this meeting that we're having over the next 2 days, and then to go through the gamut here of looking at the standards that are incorporated by reference. We need to consider the new types of facilities, including small scale. What are some of the new technologies that we can bring to bear on the challenge that we have? Look at the incident history, and then ultimately we will end up with a notice of proposed rulemaking that will ultimately come out at the appropriate time that will update Part 193. I would estimate that would be, it won't be this year. It could possibly be next year, but this is a very we need to take a careful approach, a methodical approach to developing an update to the standard, but that's sort of the general plan we have. I would add too that we also have a plan to update the incorporation by reference, the standards that we used to that we reference in Part 193, and that will probably be a separate rulemaking before we do the sort of the general overhaul of 193. Now here's just a smattering of who we have here today, and we have a broad group of stakeholders here. And appreciate this slide that was put together, these two slides, as far as who we have. I know it's kind of hard to read there, but we have the full gamut of stakeholders that we deal with on the federal government side and the state side as well, because the states and PHMSA are joined at the hip regarding LNG policymaking. And then many from the non-government entities, you know, the NFPA 59A committee, members of the Fire Emergency Response Community, the full gamut that you see here that deal with LNG. Now I think I might turn it over at this point to Ken Lee, our Director of Engineering. Ken, I'll introduce you to kind of do the tag team here. I'll turn it over to Ken, who will talk a little bit about our LNG research projects that are going on, and to then introduce I guess the first panel. But again, welcome. It's a pleasure to have you here today, and look forward to a very robust and constructive dialogue on the topic of LNG. But Ken?
Thanks. Thank you, Alan. Good morning, everyone. My name is Ken Lee. I'm Director of Engineering and Research here in the Pipeline Safety Office at PHMSA. I want to welcome everyone to US DOT and for the big turnout, and I want to welcome everyone on the webcast. And I want to thank everyone for your interest in LNG safety. We're looking forward to our speakers. I want to thank them for making the presentations today. And I also want to make the webcast presenters, the webcast attendees aware that the schedule may change to accommodate the presentations today. And a reminder to those of you here, if you do leave the building, you'll need to turn in your badge to leave, and then you need to pick up your badge again at the registration desk in order to re-enter. So that's, you know, through your left here. I want to talk briefly about our research program. PHMSA has a robust pipeline safety research program. Right now we have over several dozen projects, mostly focused on pipelines. And this is to advance safety, to provide near-term solutions to improve pipeline and LNG safety. And I want to focus on two of the projects which we have, which are highlighted on this sheet that you could pick up at that table there in the back. And the two current projects are on gap analysis of the LNG failure rate tables, and the other one is on exclusion zone calculations and vapor dispersion modeling tools. And we have a R&D forum every 2 years, and we'll be having the next one in fall of 2016, where we invite you to come. It's a public event where we want all stakeholders there to identify what the biggest R&D needs are in pipeline and LNG safety. So we'll have public, experts, us there, and trying to try to discuss, you know, what the biggest needs are, where our R&D dollars should go. So that will be announced on our meetings webpage, which is the same webpage that you can find this meeting. It will be announced in the next few months, and that will be in fall of 2016, date and location to be announced. So I'm really looking forward to these presentations, and I think, you know, I really want to hear them. So without further ado, I'd like to hand it off to Joe Seavey, who will now introduce our speakers.
Good morning. Our first guest speaker this morning will be Robert Shafton. Robert Shafton is an Engineer 3 with the Delaware Public Service Commission. Robert has performed inspections of peak shaving facilities for the past 16 years. For 14 of these years, he has been the solo pipeline safety inspector of interstate transmission, distribution, and propane systems. Robert has a BS in mechanical engineering from the University of Delaware. And at this time, let us give a warm welcome to Robert Shafton.
Good morning. Good morning. My first slide here is to talk about one of the peak shavings in the state of Delaware that I have spent a considerable amount of time inspecting. I don't know if you can see this, but this slide indicates some of the statistics on the plant, which is operated by Delmarva in Wilmington, and with a feed flow of 2.85 million standard cubic feet per day, at a pressure of 150. Liquefaction capability of 1.5 million cubic feet per day, and it would take 167 days to fill the tank, which is about 72,000 gallons of liquid. And it can vaporize 50 million standard cubic feet per day. It's used 50 million standard cubic feet per day. 1 million standard cubic feet per day is used as fuel gas. And holding operations, the boil-off gas of 0.15 million cubic feet per day at a discharge pressure of about 30 psig. And generally, it takes most of the summer to fill the tank. In 2014, in July, it started out at 27 feet, and by the end of the period of liquefaction was up to 90 feet. And in 2015, started out at a tank level of about 36 feet and concluded at the end of the year in December 11th at about 90 feet in the tank. And next slide indicates the liquefaction for the past 5 years. As you can see, it does vary over those 5 years, and I would say mostly because of the demand based on the weather in northern Delaware. So, and the next slide indicates the areas of that I emphasize during my inspections as an inspector. Inspection of the plant's operating procedures and maintenance plan, inspection of the plant's monthly preventative maintenance schedule to verify that the operator is scheduling the maintenance activities and maintaining a complete record for the plant, component preventative maintenance, inspection completion cards. Basically, a record is maintained for the maintenance items, identifying the component, the date, type, maintenance activity performed on the component, a liquefied natural gas liquefaction daily log, vaporization log, and daily plant operations checklist, I check all of the data that is recorded by the plant operators to ensure that the readings are normal and consistent and within the proper operating range. Checking of pressure, temperature, flow instrumentation on the control room panel, and inspection of readings on the local control panels for the molecular sieves. Nitrogen cycle compressor, which is a closed system. Nitrogen expansion turbine, booster compressor, and the cold box and blow-off compressors. Visual inspection of the compressor room, compressor motor starter, and motor control center. Instrument air system, nitrogen supply system, fire protection and control system, and storage tank, molecular sieves, expansion turbine, booster, compressor, and cold box, and other areas, the send-out area and the cooling water system. And in particular, I check the safety relief valves to make sure they've been inspected and tested, and that the valve lifting pressure is within the reseating compliance requirements of 193.2607, 193.2619, and 193.2639. Basically, the liquefaction log lists components, the lines, valves, and instrument number, and a description for which temperatures, pressures, and flows are physically checked and recorded by the plant operators every 2 hours. Most of the time, the operator spends their time in the control room viewing all of the instrumentation. And moving on here, the next slide, the general plant safety prior to and after the startup of liquefaction, records review of the processes, vessels into which the natural gas or other hydrocarbons are introduced must be purged with nitrogen to remove any air in the system, molecular sieves, cold box lines to storage, and if they, especially if open to the atmosphere, and purging is done by pressurizing with nitrogen and depressurized through all available purge points until an oxygen content of less than 6% is obtained. Another critical area of my inspection is cool down. LNG must enter the warm piping systems at a control rate to avoid high thermal stress and overpressurization. Any lines with LNG in them must not be blocked off for any appreciable length of time because pressure can build up to a point where pressure relief valves would be actuated. During cool down, plant operators must visually monitor LNG piping equipment and components during the cool down in order to detect any unusual movements or lack of support piping equipment and components, leaks that may develop at flanges, valves, valve packing, and seals as a result of the cool down process. And the person performing this inspection is in full communication with the operator responsible for controlling the cool down to avoid excessive stresses on the piping equipment and components to ensure everything is safe. Upgrades made to reduce interruptions to the LNG liquefaction. Some natural gas purification and refrigeration system repairs, upgrades were made. The original transformers that dated back to 1972 were replaced with a new 2000 kVA transformer. Repairs to one molecular sieve absorption vessel that had developed a crack in the bottom, and replacement of molecular sieve valves which open and close during absorption, depressing / heating, and cooling / pressurizing. Some of the piping and insulation had also been replaced. sensitivity of an auto transfer switch between two circuits. A new switch had been installed in 12/16/09. Replacement of the motor starter also had occurred that drives a two-stage nitrogen electric motor-driven compressor. And some of the equipment issues that had resulted in shutdowns, a broken compressor rotor bar and replacement in 09. And outboard journal bearing replacement that included dipping and baking of the motor stator windings. Thrust bearing collar had loosened, causing electric motor and gear unit vibration shaking, and they had to replace thrust and journal bearings in June of 2010. Compressor had to be removed from the bed plate and complete overhaul due to problems with seals, and this was done in March of 2015. There had been a helicoid score on the shaft, so that repairs and replacement of worn components were made. That was done by Houston Dynamics. Expansion turbine, these are just some of the dates involved with the expansion turbine booster compressor. It was August of 13, axial thrust bearing issues were addressed. In July of 2014, operator prepared to reinstall the turbo expander boost compressor in July of 2014. And in March of 15, the expansion turbine and its housing were removed and the turbine sent out so the bearing housing could be drilled and tapped to accept new vibration probes, vibration detection requirement. The nitrogen expansion turbine needed to be disassembled, turbine and compressor wheels removed, and the shaft burnished in the area where the vibration probes view the shaft. And in October of 15, a new Fisher booster compressor bypass anti-surge control valve was installed with positioner, and that resulted in a 2-week shutdown. The molecular sieve system, various dates here on 5/25/11, there's an upgrade of the molecular sieve system, replacing the pneumatic valve actuators and solenoid valves. In the fourth quarter of 2012, that's essentially the valves were replaced. And then some machining had to be done because they had some interference fits with some of the valves, and that was done in July of 14. And as noted, there was a crack in the bottom of the molecular sieve absorption vessel. Then that was down for 1 week in 10/24 through 10/30 of 2015. So some of the new upgrades to the plant were a new Allen Bradley motor control center was installed, replacing the original installed in 1972. New local control panels for the molecular sieve system, the nitrogen expansion turbine, booster compressor and cold box, and for the boil-off compressors. In addition, new temperature, pressure, temperature indicating, and flow indicating measuring instrumentation has replaced older instrumentation in the main control room panel. They've added a new tank leveling system and Honeywell NRAF system, which can stop every several feet and descend to the bottom of the tank and can determine the density. And some of the other upgrades was to rebuild, overhaul the boil-off compressor system to ensure more reliability. Included new dresser ran controls with feedback sensors to measure temperatures and pressures at key critical compressor system locations. And secondly, rebuild, repair of the single-cell cooling tower. That included replacing the honeycomb material and the water curtain, replacement of the cooling tower outer plates, and relocating the motor outside of the airflow stream to increase the reliability and to reduce the amount of corrosion. Other upgrades to the plant, some new piping supports, 12 new high-resolution digital safety cameras in 2010, a new guardhouse in 12, new Siemens control panels for the molecular sieve system, and the Allen Bradley local control panel for the nitrogen expansion turbine booster compressor. And they did some testing of the functionality of the Ansel portable Purple K automatic extinguishing systems and new LED perimeter systems. And I wanted to, move on to vaporization. The Massillon in 2011, a rotary control valve actuator was installed on the LNG line valves located near the LNG pumps. Some additional jacketing on the vaporizer lines, and so a number of things here. Original equipment. Foxborough pressure control loop, transmitter controller positioner on each of two vaporizers was replaced with Siemens digital controller, electronic pressure transmitter, and digital positioner. Okay. Some remaining electrical issues, reliability due to external power issues has been improved, but the transformer upgrades do not rule out the possibility of electrical momentaries, surges, dips, overcurrent, undervoltage, and phase imbalance or lightning strike issues from a feeder substation which supplies the electric to the LNG facility of Delmarva. Future peak shaving projects that are planned. An upgrade of the fire alarm system, including replacement of high temperature detectors for fire detection alarm and combustible gas detection monitoring system with a state-of-the-art system. The present system is an old technology Delphian methane detection system, and they're looking at replacing that with a UV IR, and hopefully that will get installed by 2020. They've had some problems with the insulation for the booster compressor, which has had some problems with some micro cracking, and that's basically they've got a backup in case there should be a failure of that. Installation of a splash shield at the base of the LNG tank, and miscellaneous projects to upgrade various transmitters, controllers, and valves. And basically, they've been very proactive at making investments in the plant to ensure the safety and reliability of the plant. So they've definitely put a lot of emphasis in keeping the plant, trying to modernize the plant and also ensure its safety. I thank you. Thank you. That's my perspective as the pipeline safety engineer in Delaware.
Thank you, Robert. It sounds like you got your hands full. Our next speaker is Jay Jablonski. Jay Jablonski is Vice President and General Manager of HSB Professional Loss Control, the property group within Hartford Steam Boiler Inspection and Insurance Company. He has been involved with property loss control and fire protection engineering since 1980. He currently manages property loss control services for HSB, involving over 200 site surveys per month, both in the United States and overseas. Jay's experience includes project engineering with an international fire protection contractor where he specialized in the protection of LNG facilities, offshore platforms, and other energy-related facilities. He has been responsible for development of conceptual design philosophies, technical specifications for suppression and detection systems, hazardous analysis, and system application surveys. Jay has been a committee member of NFPA 59A, standard for the production, storage, and handling of liquefied gas since 1997, and has been the committee chairman since 2006. Let us welcome Jay Jablonski.
Thank you. As Joe said, to give a little bit of my background of what I've done, I'm actually a fire protection engineer from the Illinois Institute of Technology. So that's where I start. I'm known as the fire guy within our company. No, not switching yet. There we go. I'm going to give you a brief introduction to NFPA 59A, kind of a bit of the background of the standard, where it's come from, and a little bit of where it's going. Talk about some of the changes that have occurred in the standard since the 2001 edition. I'm going to talk a little bit also about PHMSA, what they're looking at in terms of adopting NFPA 59A, and then touch on the next edition. So as a background, the American Gas Association, really the ones that were started the project to actually get LNG, to get a standard in place. So that was back in 1960. They put together a draft standard, submitted it to NFPA, and then in, 67, can't read my notes, the first official NFPA 59A was adopted. At that point, it was really based on protecting peak shavers. Things have changed since then, and we actually broadened the scope of what we cover. Our general purpose is to provide a minimum fire protection, safety, and related requirements for LNG plants. And again, it's a minimum standard. NFPA standards are typically written that way. You can always do above and beyond that, but we feel we set the minimum requirements to have a safe facility. Show a picture of a facility in Barcelona. NFPA is not just the United States standards, though that's where it's predominantly used. We like to think that we are internationally used also. So what does 59A cover? It applies to facilities that liquefy natural gas. They handle it, they move it, they store it. They have training for people that run these places. There's also a number of things it doesn't apply to. One of the ones that you may see if you're in the industry is frozen ground containers. We don't cover that as part of our standard. We also don't cover portable storage, and probably one of the bigger things that with what's going on in industry right now is vehicular LNG. Whether it's automobiles, trucks, trains, shipping or ships, that's not part of our standard. Yeah, I know. Little feedback there. What I want to do is also talk a little bit about the process that NFPA uses for developing their standards. It's a balanced process where we have a technical committee made up of various different groups. I've got the list up there. You've got testing, consumers, enforcing agencies such as PHMSA, DOT, installers, folks who actually install the type of equipment, insurance, which is, I'm a member of the insurance group, labor, manufacturers, and then special experts and users. So a lot of those folks are probably represented here in the audience today. We also have a balance rule in place so that you can't have one group basically run the committee. No more than 1/3 of our members can be from any one of those 9 groups. There's also requirements for a consensus. So if we've got rules that are being changed, we require 2/3. Oh, no, come on up.
You got to talk directly into it.
Okay. How's that? It was too far away. Huh? I thought it was too close. So we've got a 2/3 requirement on changes in the rules. So again, we don't want one single group to dominate a committee. Our current makeup is, as you see on the list, is predominantly special experts. We've got 30% or 9, followed by users of 8. So those are our 2 biggest groups. Ken had his PHMSA folks raise their hands. I think we've got a lot of NFPA 59A committee members here today, and if you could raise your hands just to show the audience our participation. So as you see, we could probably have a committee meeting. We've got enough members here today. But again, we look for people who are the experts in the industry, who want to be involved and can bring some expertise to our group. We also have alternates on the committee who, if the principal member can't attend or is unable to vote, we have alternates to do that. So about half of our principal members have alternate members that support us also, and they might bring some special expertise to the group. So I want to go quickly over the changes since 2001, because that was the edition that was adopted by Part 193, and I'm going to hit it kind of at a high level. If you went through and looked at all the changes, we could be here for 2 days. I've got a document of 190 something pages long to do a comparison between those 2 editions. So there's a significant amount of changes. So we've reorganized the chapters. There's been changes to reference publications. There's been a lot of changes with tanks in terms of what was covered, what wasn't covered. I'll go in each one separately. First off, we'll start with chapters. If you're familiar with NFPA 59A, we now have 15 chapters. It was really a reorganization that was driven by the NFPA manual of style in terms of organizing all the NFPA standards in a very similar format. One of the things we have is the annex material. Many people are unsure what that really means, the annex material. It really is explanatory information that's not the body of the standard. It's written in a should type language. The code itself, chapters 1 through 15, are basically mandatory requirements written in the it shall be done language. So there's Appendix A, which is the annex material that references various sections within the body of the standard. So if you've got something in chapter 5 and item 5.2.1, there might be an annex item that the committee put together that gives additional information or explanation to what the committee's intent or meaning was. It's not enforceable language if it's adopted. The annex is really just explanation material. The rest of them I'll quickly go through. B is for seismic design. C is for security, which is based on the 49 CFR 193 subpart J, Appendix J. So we've actually incorporated that in there. We've got a section on training, D, and then there's informational references, Annex E. So chapter 2. Again, I'm just going to hit some of the highlights and not hit every chapter. This is the reference documents. These are the documents that, as part of the standard, they are incorporated by reference. We go through this every cycle, which is about a 3-year period, and decide which standards are going to be referenced, which version of the standard is going to be referenced. One good example is in the 2001 edition, we referenced the 1992 Boiler Pressure Vessel Code. In the current edition, which is the 2016, we adopted the 2013 Pressure Vessel Code. So again, the standards that we adopt have changed quite a bit over those years, and we try to stay current with that. It's a big project as a committee, but it's something we feel is necessary to do. So we typically have a task group that goes through the list and says, here's where we are in current standard, what's changed, what are the new standards, does it make sense to adopt whatever that next version is. So one of the changes is in the definition section, Chapter 3. We defined a component, a facility, and a plant. There's been a bit of confusion over the years in the use of facility and plant. So we actually tried to define it better so that you've got a component, a piece of equipment within a facility. A facility is something that actually handles and makes the LNG, vaporizes, stores it, whatever. And then a plant, which could be a multiple facilities within one location, functioning as a unit. So again, trying to standardize on that, make sure it's understandable to industry. Also in Chapter 3, we have definitions of containers. Again, a big changes that occurred since the 2001. We're addressing different types of containers: pre-stressed concrete, single containment, double containment, full containment, and membrane containment. So those different types of tank or container systems have been defined in that chapter. Again, changes from the 2001 edition. Probably one of the bigger changes, until I get to the end, is plant siting and layout, Chapter 5. This is near and dear to most of the folks involved in the LNG industry. So we've had a lot of changes in terms of what we do on siting of equipment, facilities, distances to property lines, distances to different occupancies. We added a model evaluation protocol for vapor dispersion. The 2001 edition had a very specific saying, if you're going to do vapor dispersion analysis, use this. Now we've got actually a evaluation protocol that allows other software, other methods to be used instead of just the one very specific. We've added some differences in terms of spacing on thermal spacing, allowing for some credit on active and passive systems. Again, a big change. The siting criteria from a spill design has been changed over the years, mainly based on the type of tankage that's in place. So big changes there. We've also gone to a number of different classifications for buildings where it's from seismic, wind, ice, snow. We've classified them as an A, B, C, and you can look it up in the standard. I'm not going to go through what the details are, but again, changes on how you design these buildings. We've put in some additional requirements for portable LNG, which really wasn't much there back in 2001. And now there's more emphasis on concrete design, so we've added a reference to the American Concrete Institute. Oops, wrong way. Storage tanks. I touched on that briefly with the definitions, where we've added different types of tanks into the definitions. Chapter 7 is the one that talks about the design of those tanks. What's required for design of the tank, for inspection of that tank. It has a lot of reference documents in there where we're tying to other standards. For example, metal and concrete tank design. We're referencing API standards, American Petroleum Institute. Also for concrete tanks, we go to the American Concrete Institute standard. There's seismic considerations that we now do for the American Society of Civil Engineers. Again, all these are standards that we felt have changed over the years that needed to be incorporated because they have the best practices to be used for the standard. Same thing, inspection and testing requirements. There's some changes on ASME containers where we're storing above 15 PSI. And then there's also Chapter 13, which covers ASME containers up to 100,000 gallons. So a lot of changes there in terms of the storage tank requirements. Piping system and components, which is now Chapter 9. Same thing, we talked about what the requirements are for piping. There's a definition of process piping, which sometimes brings up an issue with what is piping within a facility. We reference ASME B313 process piping, and that is for piping that is not part of the LNG container. There's a separate requirement for piping that's part of that container. So again, some changes there. we define the materials of construction for the piping, what the requirements are in terms of suitability for its use, whether it's for cryogenic LNG process or whether it's for, say, ambient temperature type processing. So again, we look at those requirements, decide what standards need to be followed, and typically adopt those standards and maybe add additional requirements beyond it. We've got inspection testing requirements for the piping systems. And then we also addressed, which is, again, relatively new, is the cryogenic pipe-in-a-pipe systems. I know one of my speakers following will talk a little bit more about that, so I just wanted to at least throw that out there that, again, this is something that's been changed since that edition. One of the bigger changes is the performance-based chapter, chapter 15. In the 2001 edition, that did not exist at all anywhere in the standard. So from looking at changes, this is probably one of the bigger ones that we've had. In the 2009 edition, we added this as an annex chapter, or appendix. I believe it was called an appendix at that point in time. And that was put out there to say, here's some information that the committee thinks is important, is a way to go forward, looking at risk-based assessment of a facility. But at that point in time, we didn't feel comfortable enough that we wanted to make it part of the standard as a requirement. So we put it in the annex item, able to get input from industry, interested parties. We made a number of changes while it was in before we moved it into the body of the standard, which was in the 2013 edition. So this one is basically a alternative to the more prescriptive siting requirements that we have in Chapter 5. There's a lot of information there. One of the key things is it must be approved. I had a discussion earlier about what does approved mean. It means that the authority having jurisdiction, whoever that might be in the specific situation, approves that method of doing your siting. So again, that was a big change. We added information in terms of how you calculate the risk to the people, looking at what some of the possible failure modes might be, looking at frequencies, severities. So it's a requirement to do it in a different method from the prescriptive requirements, but it also requires you to do it on a regular basis if you've basically revalidated every 5 years, or if you've made significant changes. Let's say you've added another liquefaction train. You'll want to redo that analysis to make sure your changes didn't affect your initial assessment of that facility. So it's got a lot of information in it, and there's a lot of things changing in that. I know one of the things we talk about is looking at the data in terms of what frequency should we use for failures. There's information out there, and there's new information being generated, and as a committee we always look at that and say, are there things we can do to improve, make it better, add additional information, make for, again, a safer facility. Next, I want to touch on PHMSA's adoption of the newer editions. And again, this is from my perspective, not from PHMSA's. We'll hear a little bit more about that later on. But the plan is to review the current edition of NFPA 59A. They have really three options. They can adopt it in its entirety. They can adopt certain sections of it, kind of a cafeteria style, I guess is the way to put it. Now, if they want to adopt this section, not that section, maybe they feel Chapter 5 is appropriate and Chapter 15 is not. Again, that's the decision they have to make. Or they don't adopt it at all. They leave it as currently 193 adopts the 2001 edition. So ideally, the goal would be to get to the point for the next edition, which is the 2019 edition, that there's agreement between the committee, the users, all the participants, that the 2019 edition could be adopted in its entirety. Again, it takes time to adopt a standard. It takes time to change rules and regulations within the federal government. But I think we're making some good steps forward, some good discussions. We've had a couple meetings where we've talked about some of the points that I'm going to bring up next. So from my viewpoint as NFPA committee chair of 59A, I think we're seeing some activity where in previous years there was very little back and forth between the groups. So I'm looking very positive, and I think this meeting itself will hopefully bring up a lot of ideas that both sides, both NFPA and PHMSA, can say, those are great ideas, we need to adopt them, whether it's in their standard or ours, and go forward. Some of the issues that we're running across, again, I'm just going to touch on them very briefly. Qualitative risk assessment, the failure rate database. There's information that's out there that's different and new that possibly we have already adopted in our standard, and then the decision has to be made. What is the right data? Does it make sense to use data from different industries? Does it really apply to the LNG industry? So picking that data is a very important part of making sure we go forward with the risk assessment based side of it. One of the concerns that was brought up is the lack of certain hazards in NFPA 59A. We typically are more involved with the fire and explosion, the gas dispersion. We're not as concerned with the toxic side, what could happen with a release, whether from a toxic standpoint. So that's one of the things that, again, there needs to be some discussion. Maybe NFPA needs to improve, add some additional requirements, or it could be something that PHMSA handles on their own separate from 59A. PHMSA has their LNG frequently asked questions, which has a lot of good information in it. So the question is, do we need to make sure that some of those would be appropriate to be within 59A? If there's good information, and from my standpoint, it brings a safer facility, we look at it as a possible change to our standard. Another issue is the natural hazard frequency. The current 2013 edition was, I'd say the 2013 edition, we used a 100-year natural hazard frequency return period. The federal agencies have different requirements for that. So again, there's a little bit of a disconnect between what we're looking at and what they're looking at. So that there needs to be something addressed there. Impoundment and siting types. There's a number of models that can be used for siting of impoundments, whether it's from gas dispersion, thermal. There has to be some consistency. We have our requirements. PHMSA might have slightly different requirements. So it's, again, making sure that we're using the appropriate models that give us the best results, best answers to give us a good facility. There's been some changes in shop built container design requirements. I think I touched on it briefly just with the boiler pressure vessel requirements. So again, those things have changed over the years, and there needs to be some agreement on which way we go forward. On process piping, and I'm not the process piping guy. I've got an expert in the back there who's my process piping guy. There's questions on how ASME B31.3 is applicable to an LNG plant. So the decision has to be made. Does it apply? Doesn't apply? What's its limits from one point to the other? Does it start here? Does it end here? So again, it's just a matter of getting into agreement. Couple more points. One of the things we did is some of the other hazards were removed from the body of the standard to an annex item. And again, from PHMSA's standpoint, their concern was that if we move other hazards from the body of the standard, would that mean that a user or a builder would not have to apply that requirement because it's now an annex item and is now just a reference? So again, that would have to be addressed. And one of the final things is the small scale, which we'll have some other speakers talking about small scale siting. The concern was, is the current standard as written correctly addressing the small scale siting issues? And as you know, look at the history of NFPA 59, we really started on the big stuff, the peak shavers, the import terminals, the export terminals. So are we in the right place on small scale siting issues? So again, it's a discussion that's ongoing, and we'll have to decide what is the correct way of doing it. Is it a prescriptive basis? Is it more of a risk-based method going forward? So that's really it in kind of just a very high level of where I see it from an NFPA's committee standpoint. But the next point I want to bring up is our next edition of 59A is in the fall 2018 revision cycle, meaning it will be adopted in fall and issued in 2019. Public comment is open right now, and it closes in January of next year. And input is accepted from anyone in the public, whatever reason they have to submit a comment on our standard. So we value any input we can get. Now, when you have a group like this, with all the expertise in one room, I would hope that, based on the discussions we've had over this day and tomorrow, that there's a lot of things that can be done to improve our standard, to make it better, to address changes that are going on in the industry that some of you may be aware of that we need to address. And I would really value getting the public input from this group. So I'm hoping that on Wednesday, so on Friday, when everyone gets back to their office, they go down to the NFPA.org. There's a link there, and start getting their public comments in on changes and improvements that we can do to the standard. Doesn't mean it's going to happen. It has to go through the full process. The committee reviews it. It goes out for review by the public and comment again by the public. But again, I'm looking for this group to provide information to us. Use your expertise and knowledge and make this a better standard. And I think making our standard better, working with PHMSA, we all win in the long run. So again, I'm looking for that. And with that, that's my presentation.
We have a couple minutes for Q&A. Does anybody have questions for Jay? And if you could, now can you hear? If you could also tell us your name.
Hi, good morning. My name is Cecile Schofield. I'm from Florida. My question is, it seems like we've made a giant leap from the 2001 edition to now we're looking at maybe 2016 and beyond. What happened to the 2013 edition? Because it's a risk-based, and we have a facility in Florida that's a FERC jurisdictional facility. Their current environmental assessment used the 2001 edition, and my feeling is that they probably wouldn't pass muster had they used the 2013. And so the other question is, would this facility be grandfathered in to use 2001, or should they be using 2013?
Okay, I think I can answer it, but it's really more of a regulatory question than an NFPA question. Typically, when a facility is built, it's built to the standard that's in force at the time. So if it was built to the 2001 standard, that's what follows. That's what it has to follow. Just because a new standard comes out doesn't mean that you have to go and update your facility to the 06, the 09, the 13, the 16, the 19. It's not built. Okay. So it really is a regulation requirement. So if it's underneath FERC 193, they've adopted 2001 edition, they have to follow those rules. So there may be someone who can answer it more from the regulatory side, but again, that is my understanding, is from the NFPA view.
Eric Swenson with Norton Rose Fulbright. On the move to risk assessment, there's been a lot of talk about the difficulty the public has with really understanding risks, and it's so much easier for the public to sort of say it's met the prescriptive standard, I'm safe, I'm done. When you start talking about things killing X number of people over Y number of years, the public, there's concern that the public has a hard time getting the grasp of what that risk is relative to the risk of crossing the street or just sitting at their desk. So what has factored into the committee's thinking on moving towards risk assessment and how you'll gain public acceptance for that?
The public assessment part or acceptance part of that is actually relatively difficult, as you said. I've run into it a couple times on some projects I've been involved with. It's difficult to say that a person understands that there's a risk in so many per million years you're going to have a certain type of injury. What we've done before, this is not from the committee, this is again just me, you have to almost look at it and say, okay, the risk of getting hit by crossing the street is X. The risk of getting killed in driving a car is a certain number, and you compare that against what the risk is based on the analysis you do for your facility. Unfortunately, that doesn't always work because some people say, yes, I accept the risk of driving a car. I don't accept the risk of this LNG facility because it's not the same. I'm not used to it. And I don't know how you educate enough of the public to understand when you try to look at risk that we're making very, very comparable risk numbers, but they mean completely different to the perception of the public. So I don't know if there's a real easy way to do that. I mean, it might be something that you'd look at from an annex material, trying to give that explanation, saying we look at a failure rate of some number, which is similar to something that the public can easily relate to. But again, it's always the perception of the public of that risk. And it may be identical to something they accept every day, but they don't accept it because it's different.
Hi, Jenny Mandel. I'm a reporter with Energy Wire. Can you talk a little bit about the previous 59A editions? And in this case, you said that there's a goal of working towards full adoption in 2019 and probably partial adoption then, it sounds like, most likely this time around. Can you give a little context of the past few years since the 2001 edition, what the goals have been? Have you worked closely with the agency or with regulators in this kind of a way, or how is this the same or different?
Okay. We've worked with the agency. In fact, we've had members from the agency as committee members probably back before I've been involved in the committee. So we do get their input as committee members, so we always ask for that. We normally try to work with PHMSA for DOT, the Coast Guard. Again, we try to get their input as we go forward. We'll schedule meetings to go over some of the changes that are going on because they are very important because they're the ones who actually adopt the standard and then regulate against it. So we've had discussions over the years with the various editions, and I think just recently, this last number of months, we've had some very good discussions in terms of wanting to move this to a closer relationship, to move it forward quicker. So I see, from my viewpoint, I've seen improved communications and relationships over the last number of years from where we were in 2001. So I don't know if I can answer any more specific than that, but again, I see very positive things happening. This meeting, again, being another example of that.
Hi, Jay. Terrence Wells with Lloyd's Register. Jay, just want to invite the question concerning the marinization of the LNG industry and the introduction of FLNG units, FSO, FSU, FSRU, et cetera, and how that relates to the future development of the 59A standard.
Once it leaves the shore, NFPA doesn't touch it. Onshore? I couldn't hear you.
Sorry, Jay, for at-shore facilities.
Oh,
so
at-shore, I'm sorry.
Moored to the...
I don't know if I have a good answer for you at this point. I would just be guessing. Unfortunately, I don't have an answer.
Is there any interest within NFPA? Is there any interest in NFPA to develop liquid fueling standards?
So liquid fuel standards, so the vehicle side of it? Yeah.
There are multiple applications.
Okay. At this point, our standard really doesn't, as I said, we don't address the vehicle side of it. Whether NFPA decides to go forward with something on that, I don't know if we're going to go anywhere with it. So I can say I don't know if we're going to go anywhere on the vehicle side. I would expect, because of the interest and the growth in that there will be something that will be developed over time. Scheduling, I don't know. Any other questions?
I have one more question. It's Cecile Schofield from Florida. The Department of Energy is granting export authorization to many of these new so-called small-scale LNG facilities. These facilities are not regulated by the Federal Energy Regulatory Commission. They have not met the requirements of Title 49, particularly NFPA 59A. Are you aware of this? And if so, what's being done about it?
Yes, I am aware of it, but again, I think your question is how does the federal government regulate those, or should they be regulated, and what do they need to do to regulate them? And unfortunately, I can't answer that question. You could take a small-scale facility and follow the requirements of NFPA 59A, and in theory, that would meet the requirements of what the regulator is looking for. But again, it's two different sides of a problem. One is the regulations that apply or don't apply. The other is NFPA 59A, which you could use to design, maintain, inspect your facility.
Thank you for the question. We're going to need to head on to the next speaker.
Thank you very much.
Thank you, Jay.
Thank you, Jay. Good discussion. Our next speaker is Professor Sarah Gossman. Sarah Gossman is an assistant professor at the University of Arkansas School of Law, Fayetteville, where she teaches and writes in the areas of environmental and energy law. One of her primary research interests is the use of risk regulation to govern oil and gas development and transportation. She is also vice president of the board of the Pipeline Safety Trust, a nonprofit organization focused on improving pipeline safety from a public interest point of view. Prior to joining the School of Law in 2014, Professor Gossman was a lecturer in environmental law at the University of Michigan Law School. She has practiced as a water resources attorney at the National Wildlife Federation and as an assistant attorney general in the Environmental Division of the Michigan Department of Attorney General. Sarah is a graduate of Harvard Law School and the John F. Kennedy School of Government of Harvard University. Please welcome Sarah Gossman.
Hello, everybody. Can you hear me? You can hear me. All right. Well, thank you. So I have a difficult task today, which is to talk from the public point of view. And I will say up front that I can't speak to the entire public, so I will speak to a particular public, which is myself, plus what I understand from the Pipeline Safety Trust. And I do sit on the board of the trust. As you heard, I'm interested in this both from a research side, I teach, and also from a teaching side. I teach energy law, I teach environmental law. And one of the things that I'm most interested in is thinking about risk. And I feel like the person here just set me up nicely, because risk communication is absolutely where I want to go with this particular presentation. So and I do want to thank PHMSA for inviting me and for having me here. So I will start out by explaining how I think about the regulatory framework, and I do this in order to get a sense of how the public then interacts with this framework. So when I think about the framework for LNG, and I'm going to focus particularly here on siting. I think about the basis, that is, what approach do we take to the safety issues? I think about the type of regulation, what form the siting requirement will take, and I think directly about public participation, that is, how the public can participate in the policy decision. So looking at the basis of siting, I think there are three possibilities and probably a lot of gray areas in between. The first I'm going to call precautionary, and I use this with this particular sense. This is not about the precautionary principle, which you might hear about and which I certainly teach about, but more a preventative approach to risk regulation. So citing as protecting the public from foreseeable harms, and particularly those harms that the public is most concerned about, which tend to be catastrophic events. When there is uncertainty about risk, as there always is, and I think one of the interesting and challenging issues about LNG is that because of the good safety record, the issue of data around risk is hard because we don't have the data. So the fact that you have such a good record as an industry means it's harder to think about than what we do in terms of predicting the future. So when there's uncertainty about risk, this particular precautionary approach errs on the side of overprotection rather than underprotection. The second basis of citing that I'm going to talk about is a risk-based approach, or here, particularly looking at the quantitative side of this, probabilistic risk assessment. And here the approach is one of efficiency, ultimately. That is, what we're trying to do is protect the public from unacceptable risks, considering both the likelihood of an event as well as the consequences. And what follows from this is that very low probability risks of catastrophic events are acceptable. Again, when there is uncertainty about risk, we take that into account in this particular approach to risk regulation, but it doesn't necessarily lead to more protection in the way that you would see in a precautionary approach. And finally, I'm going to put on the table public consent or consent-based regulation. I know this is an issue right now as we deal with the fallout, the continued fallout of Yucca Mountain, and thinking about this as a community-driven approach to regulation. So here we're making decisions about siting that protect the public from risks the community itself finds unacceptable. So rather than having an acceptability test that is devised by experts, the community is telling regulators, telling the industry what it finds acceptable and unacceptable. This acknowledges, of course, that the public may well perceive risks differently than risk scientists, than regulators, than the industry, and moreover that different communities have different perceptions of risk. Not everyone is the same, thus my initial comment about the fact that I couldn't speak for everybody, certainly on the matter of risk. When we deal with the potential for catastrophic consequences, or there is uncertainty, and these are really, of course, the two big issues with risk, the community is likely to demand more safety measures and to need more evidence in terms of trust. And there's a whole interesting set of literature about how the public perceives risk and the issue of catastrophic consequences, dread risks, as well as the question of knowledge about the risk. These are the big drivers that cause the public to perceive a risk differently than, say, a risk scientist would. All right, what about type of regulation? I'll go a little faster here. So when we think about type of regulation as a regulatory design question, we're thinking about prescriptive standards, performance standards, and then I'll sort of have an other category. So on prescriptive here, these are requirements that specify a particular action that must be taken or a particular restriction. Sometimes prescriptive requirements are tied to a broader safety goal, and sometimes not. In the siting context, prescriptive requirements can be restrictions on siting in certain areas, ownership requirements, or say a distance between components. Performance standards, in contrast, are requirements that specify a particular performance level, but not the means of obtaining that level. Sometimes it requires review and final approval of means, and sometimes not. The focus is entirely on the level itself. And here, of course, when we think about siting, we think about the performance standard as one of the risk to the public, the risk limit, or perhaps the safety performance of parts of the facility. Under other standards, well, there are a ton of other types of regulation that you can use. Certainly there are planning and analysis requirements in the regulations, but other possibilities include here information disclosure on the question of risk, or liability and insurance requirements. And then finally, the question of public participation. So here, as you can tell, I think in threes. So I'm thinking about public participation in three different ways. So as public participation through standard setting organizations, and of course we just heard about the major one, the public certainly has some ability to give input into what are private organizations, but it's a very limited opportunity, even with the best of intentions, because this is essentially a private process. And unlike agencies, standard setting organizations don't have to respond or create a record that then has to be defended in court. The places in which the public can, of course, engage with the standard setting are as members of committees or as submitting comments. So one of the things that is, of course, not unique to this particular committee that we just heard about, but is, I think, notable, is that there's not a member of the public, in my definition of the public, meaning not government, not industry, not otherwise associated with the industry, but people who live in communities and are concerned about LNG. I suppose I would include academics who have maybe more of the technical expertise. The second is regulatory hearings or comment periods. This, to someone like myself, this is the bread and butter of administrative law, and here the public participates through rulemakings, through comments and hearings for setting policy, and also through proceedings on citing decisions. And finally, I'm going to make a separate or a distinction here for robust and early partnership with the public. And I pull this out because I think this is separate from the other types of public input. Here the public is brought in at a very early stage, and partnership really means partnership. That is a discussion around risk, a discussion around how the community in particular can feel comfortable with the particular risk of any facility. All right, so I'm going to take all this and compare and contrast the current framework with what I understand of this risk-based framework. So the current framework is, I think, precautionary in the sense that it creates exclusionary zones for two worst-case scenarios, and it focuses on catastrophic events, that is, hazards, rather than on probabilities. Conservative assumptions are used in the model to make the zones even more protective. But I should note that the zones do not create absolute safety, a risk-free world. And indeed, how precautionary the zones are is a subject of dispute, as I'm sure you know well. Criticisms of the scenarios and whether the exclusion zone should be larger are definitely out there and are issues to be dealt with. The current framework, moving on to the type of regulation, is prescriptive. So Part 193 directs operators to use specific models or equivalent ones approved by PHMSA, and the safety measure itself is prescribed, exclusion zones, and those are based on the type of land use and population. As for public participation, so the public can certainly participate in the FERC process by submitting comments, speaking at meetings, but the project is quite far along even when you think about it from the pre-filing point of view. There's no similar process, at least that I could find, for intrastate facilities governed by PHMSA's safety standards, the siting standards. PHMSA doesn't issue a formal approval in those cases in the way that FERC does, but it does expect the facilities to abide by the siting standards. From my perspective, there are a number of advantages to this regulatory design and a disadvantage. So the regulatory design errs on the side of caution. I think that's what it's supposed to do. It privileges safety over cost, and it is tailored to the potential consequences of the facility, by how big the facility is, how big the pipes are, right? That is a measure of risk, ultimately, about a particular facility. So small versus large does get factored in here. It's just that overall it's a very precautionary scheme. The disadvantage, I'd say, is that it doesn't really engage the public, or in some cases involve at all the public, in these risk decisions. All right, what about risk-based siting? So here, I've set it up, and you know well that what we're talking about here for the basis for siting is probabilistic risk assessment, quantitative risk analysis based on protocols. So this is a risk-based approach that protects against intolerable risks to surrounding populations, installations, or property, taking the language from 59A. Intolerable comes, as I understand it, from the British scheme, and it was new to me. I've seen the word acceptable and unacceptable before, but not intolerable. But it's a good word. So this is based on quantitative risk analysis, and it sets limits both on individual risk based on land use and societal risk limits based on probability and number of fatalities. And so getting back to this question of catastrophic risk, very low probability, say 1 in a billion, risk of a catastrophic event with thousands of deaths, that's tolerable under the particular scheme. While relatively high probability, say 1 in 1,000, risk of a few deaths is considered intolerable. And to me, that precisely gets at the point of how risk-based is different than the current approach. It is certainly performance-based. In addition, of course, to the risk limit performance standards, there's also a performance standard for mitigation measures in 59A. For example, latest technology and instruments and plant design. But I should note that the method of quantifying risk is prescriptive. That's based on a protocol in several specific documents. How is the public involved here? Well, I think the only way it's really involved, at least as to the question of the tolerability of risk, is through the committee, right, the standard setting organization itself. And it would definitely be if PHMSA completely deferred to 59A. All right. In terms of advantages and disadvantages, so this system definitely creates flexibility for mitigation options. It doesn't just focus on the question of setbacks. On the other hand, like every single quantitative risk analysis in regulation, it relies heavily on data, on correct analyses, because we have to know what the risk is to measure it against the tolerable risk that we have chosen. And here I think one of the main things I want to point out is that the tolerable individual and societal risk was determined without the kind of notice and comment rulemaking that you would think would be a good idea for such a critical issue. And so moving forward in terms of thinking about this particular approach, one plea I would have is certainly the risk levels that are in 59A come from other places. As I understand, they come from Europe, but they haven't been vetted through the public. And it's the public, right, that is getting at this question of what is tolerable. I'd also note, and again, this is a very common criticism of this type of regulatory scheme, that it is difficult to enforce. It's a lot easier to, nothing is easy, right, but model a particular exclusionary zone and see whether it is complied with. All right, so not here, then where, right? Where do we go? So I will, because I'm running out of time, I will just note here one of my favorite articles from a very well-known risk scholar named Baruch Fischoff. He wrote this back in 1995, and I think it still applies today. He calls these the developmental stages of risk communication. Number one, all we have to do is get the numbers right, right? We're the experts, we know what we're doing the best we can, but non-communication is a form of communication, and the public takes something from that. All right, so all we have to do is tell them the numbers. Okay, but without context, right? All you have is a sense of distance and ultimately distrust. Fine, all we have to do is explain what we mean by the numbers. All right, good, explain, but in explaining, you necessarily open up the fact that this isn't actually an easy analysis, that there is subjectivity and uncertainty in the underlying analysis, and then this causes the public to wonder, okay, is this the right way of doing things? Do I trust that this is the correct analysis? All we have to do is show them that they've accepted similar risks in the past. All right, you accept these other risks, so certainly you must think these risks are all right. The public takes this as saying that they're being irrational. But risk decisions are not just about numbers, right? The public perceives risk differently because they look at things like benefits or the nature of the risk, the fact that it could be catastrophic. So just telling somebody that the number is similar or less than another number doesn't actually help in terms of risk communication. All right, all we have to do is show them that it's a good deal for them. So people certainly need information about risks and benefits, and it does mean thinking about the issue in a different way, including the possibility of compensation for risk that people are encountering. But of course, overselling the good deal will result in, again, lack of trust. All we have to do is treat them nicely. Certainly, people want to be treated with respect, and with respect does come trust. Certainly, talking down to members of the public who are concerned won't help, but talking too smoothly also will make people concerned. So what does that leave us with? All we have to do is make the public partners. That is, give them an active and constructive role in decisions about risk. Communities, non-experts, have important risk information about their own activities, the ways in which they encounter risk. A seat at the table won't make everyone like the project, but it will allow for better communication on the important issues. So I'd say that there are a couple things that I'd like to throw out there in terms of a third way, and one I've already said before. It seems to me critical that if the direction is on risk-based regulation, that there be a careful setting of acceptable risk through public hearings, through notice and comment rulemaking. And I'd argue that we already have determined some form of acceptable risk in Part 193, because as I understand it, these zones don't mean that people will never be injured. It's just that the setting of that risk has not been transparent. Second, I think one thing to think about is broadening standards to include other types of requirements. So I actually believe that exclusion zones are the best type of regulation. Perhaps you're not surprised by that conclusion. But given that there is some shifting of risk here, I also think that liability and bonding requirements are a good idea. And having just worked on hydraulic fracturing and production wells, I can tell you, of course, that that was one of the state policies that came out of that particular controversy. Certainly the broader liability. There had always been well bonding. And finally, engaging the public as a partner. So it seems to me in the developmental phase that I've just showed you, right, we're still at the beginning. We're still focusing on the numbers, right, and similar risks, and being concerned about the irrationality of the public. I think it's time to re-engage with communities about the risks and benefits of small-scale LNG, and I think that's ultimately going to be the successful approach. Thank you very much.
Thank you, Professor Gossman. At this time, I believe we've got a break scheduled for 15 minutes, it looks like. So why don't we take a 15-minute break?
I'll move down. Are you sure? Okay. What's going on? How are things at, yeah? It's not as much fun, right? there's no pit bulls. It commutes a lot worse. Yeah, I think you're moving. LNG was great. Yeah, really great. Very, Joe did great as expected, and really good. So I'll send you all those slides. The KBR ones are really good too. I felt bad. The only complaint they had was it wasn't custom enough. You know, I got brochures. Like they're brochures they give people. You and I were done with the slides, and the brochures came like 10 days before the class. You know, I can't incorporate anything. I'm not going to make changes. But no, it went great. And probably get some more. But it was, you know, training that 30 people. And you had a range, you know, like you have an engineer, you have a process engineer, an operator, and then you have like girl from camera, you know, which is fine, you know. But yeah, Joe did great. It was great. Boy, Houston, you know, impressive. I mean, it's like their, you know, their big fancy petroleum hubs were. Some people there were people that are working on. Like there were no power lunches going on. So, but yeah, so everything's good. Girls are good. Yeah, I'm leaving here tonight. I won't be here tomorrow. Matt graduates on Friday. You're just. I might stick. Who am I kidding? I'm not coming home. I got so much to do on this. I felt bad. You know, UVA graduation's gonna be lovely. It's gonna be this weather's awful. This is. I love the. I was like, I don't need a coat. I get out of my car. I'm like, okay, all I have is my obnoxious UVA mother coat. My orange coat that just horrified my kid. It was really, I'm like, oh jeez. I mean, literally, I'm like right outside the National Stadium, and okay, the orange coat. You know it's 50 degrees. Are you? Yeah, you around? Okay. I'm gonna probably. I don't see. I'm gonna take Bob Campbell lunch, but if you want to come and walk, right? It's not that much work to get in and out, right? In and out of here. It just depends how many people. Yeah. Okay. Once I'm done, all right. Well, I'll come find you after this break. All right. Thanks, buddy. Nice to see you.
Good morning. Hi, Kevin Ritz. Nice to meet you. I guess they moved Joe around a little bit.
Yeah, I know. I did that. You probably know a bunch of the GTI guys, huh?
Rich Coy?
Yeah, he's great.
Yes. Yeah, I just met with him.
A gentleman and a scholar.
At our AGA meetings.
He's a sharp guy. He's one of those guys that, you know, you send him an email and he's back like 20 minutes later and you can tell he's read everything, he's got comments. And
yeah, he's very thorough.
Very thorough.
they mention anything? Are all the speakers going to be using the desk mic in this one?
I'm probably up there.
Okay.
I'm guessing, but
I know I requested this because I got a bad knee, so I'm standing for a
yeah,
half
I'll
hour.
probably be up there. I'll be fast. Mine is exactly the issue addressed with, first responders are great and we can train them, but these are all greenfield projects, these small-scale LNG projects, where you need to train all the stakeholders. We put the word out in Jacksonville, and then next thing you know, we had sheriffs and paramedics, and
Did they change the order up any?
I go first. You know.
Okay.
I'll warm the crowd up.
Please do. Mine will be kind of dry. It's more of a philosophical approach to managing over facilities.
Yeah.
And then making the points on the
I'd like to get you back to your seats, please. Could I get you to take your seats, please? I'd like to get started. Our next guest speaker is Margaret Doyle. Margaret Doyle is Senior Program Manager at GTI. She has been in the maritime and energy industry for over 30 years and is considered an expert in LNG bunkering training and related topics. In 2015, Margaret was the lead on the development for GTI's LNG First Responder Awareness Training Program, delivered in conjunction with the Florida State College at Jacksonville Fire Academy of the South, training more than 150 stakeholders and first responders in liquefied natural gas awareness. The training was developed specifically for Port of Jacksonville area stakeholders, especially local first responders, and including firefighters from the Jacksonville Fire Rescue Departments, the U.S. Coast Guard Sector Jacksonville, and area law enforcement. Margaret is also a long-standing appointed member of the U.S. Coast Guard Chemical Transportation Advisory Committee, or CTAC, and chairs the CTAC subcommittee tasked with developing recommendations for safety standards for the design of vessels carrying natural gas as cargo or fuel. Margaret also participates on the U.S. delegation of the International Maritime Organization on LNG matters. She is a graduate of the United States Merchant Marine Academy and holds advanced degrees in engineering from the George Washington and Pennsylvania State Universities. Let us give a warm welcome to Margaret Doyle.
Good morning. I hate to take you away from your coffee and your networking, so I'll try to be quick. Jay had pointed out during his presentation that he was the fire guy at his organization. And I usually have a slide in my presentation on behalf of GTI that, this many PhDs work at GTI, this many PEs, this many scientists. And if you really cull down deep enough, you'll find one mariner, and that's me. So I'm still trying to fit in at the Gas Technology Institute. Part of my presentation today is going to talk about training first responders. But if you look at this slide that talks about the LNG value chain, it's very important that you could overlay there are so many different stakeholders in the LNG value chain, not just first responders. There's Port Authority, there's Coast Guard, there's state regulators. One of the things that we learned in Jacksonville, that if you put the word out that you were putting together LNG training, that it's very important that you need to include so many other people that we didn't realize wanted to be included, people from the local hospitals. So I'm going to talk a little bit about the first responder experience, but mostly I'm going to really touch upon training all stakeholders, and that also involves creating consistent regulations. And the segue for me for this organization is for PHMSA to understand by updating 193, hopefully it's a wake-up call to other organizations that small-scale LNG is happening in this country. The big-scale project, Cheniere's project's fantastic, but as the monetization changes in the LNG value chain, that you're going to have smaller-scale projects. Again, move to small-scale LNG. The numbers for 2015, as anyone in this room knows, the natural gas industry is, the business is somewhat slow. But despite that, you do have quite a bit of small-scale construction happening. So that's what we're seeing. We're seeing a trend in small-scale LNG. I mean, I think if we had a buzzer for every time you heard the words small-scale LNG today, it'd be going off left and right. So we are moving to small-scale LNG, and one of the things that we need to understand, as you do that, these are greenfield projects, and you're going to have to include everyone, including your first responders. This is just a graphic, again, if you don't understand the small-scale LNG value chain as part of the entire LNG value chain, I'm not going to take you through it. There's a lot of smarter people than me in this room, so I won't take you through that. But kind of, that's a GTI graphic that says, okay, you go upstream and then you just move forward. And it really is very interesting to see as these projects develop, and I know Sarah touched upon it, there needs to be somewhat of a change in how the regulations are developed and how everything needs to become more consistent, starting with your first responders. And that's what we learned in our experiment in Jacksonville. What went very well, but again, we found there were more stakeholders than just the first responders that wanted to learn about LNG and LNG awareness. Small-scale LNG applications, we talked about it. They talked about it in the earlier panel. I won't go through it. You can decide, and I guess the next two slides that I have talk about the fact that small scale is all over the place. There are websites dedicated purely to small-scale LNG vessels, and in that realm, that snapshot is good enough for some players. But I just showed you in the LNG, the value chain for small-scale LNG, it's so much more. In my world, it was Harvey Gulf. It was trading Harvey Gulf. It was trading tote. It was trading, working with Florida East Coast Railway. So the spectrum is very wide, and the regulations just need to catch up. Again, this is kind of what I talked about. I said, you really the varying size. And that's a slide that we had our marketing people put together, so you understand that there's two different applications. There's small LNG carriers and LPG carriers, and there's the actual application which really applies to PHMSA, which is this smaller scale, the bunkering, the peak shaving, GTT is going to talk about their great work with their barge. This is happening, and one of the things we're running into is that you need to train all the stakeholders, and there's just not enough resources out there to train people. It's hard to do training in a slow industry. Everyone knows that. Again, that's a picture of that picture is of the guys from AGL. That's the first tote bunkering. That was about 4 or 5 months ago and went very well. That's using their bunkering skid. And again, GTT is going to talk about the bunkering barge that's being developed. But again, that's more than just your first responders. Those are, those guys from AGL are trained privately by AGL. There's just so many different pieces of the puzzle, and that's just an LNG vessel, LNG fueled vessel, a tote vessel being fueled in Jacksonville, Florida. And that doesn't even include a bunkering facility or a bunkering barge. Again, everybody needs to be trained, and we learned that quickly as we put the word out in Jacksonville, Florida, that this training was going on, and it was underwritten by quite a few companies like Tote and AGL. And again, it was, the draw was that, the fact that it was free. That can't happen all along. And we need to understand that there needs to be investment in training these stakeholders. Okay, how? Again, like I said, my background is maritime, so I've been very involved. Well, the Coast Guard has done it. That side of the manifold has developed guidance. It's not a regulation, it's policy letters. But those policy letters were not developed in a vacuum. They were developed through the Federal Register. People had plenty of time to comment on them, and they came out last year. That's one. There's other Coast Guard efforts I won't bore you with because it's not really in PHMSA's wheelhouse right now, but there are other Coast Guard efforts looking at LNG, small-scale LNG. We're here right now, changes to 49 CFR 193. This is great. Again, we realize it's just the beginning of the process, but the fact that this room is full is a good sign. NFPA 59A update, we just talked about that, so I'm not going to jump into the deep end of the pool on that one. And again, stakeholder training development. GTI is very engaged with a number of different stakeholders on developing exactly what they need, because it's really not, it's not going to fit for everybody. So what GTI has done is developed a number of modules, and I'll talk a little bit about that, but I'll try to keep the GTI push to a minimum, because one of the things I took away from the first panel this morning was we need to understand that the regulations that may, like 33 CFR 127, yes, it was great as a starting point for small-scale LNG, but it may or may not apply, and there's just, the overlap needs to be addressed. This is the policy letter. Again, this is with training. The training we developed when we trained Harvey Gulf. One of the things that we were able to do was we were able to take that in conjunction with the International Maritime Organization. The International Maritime Organization is the maritime arm of the UN. And I'm sure you're aware that LNG bunkering has been going on for quite a while in Europe. So the standards are a little bit ahead of what the Coast Guard, but the Coast Guard has basically taken that regulation developed by IMO and had it trickle down using, and that's found in their policy letter. That's a big reference in their policy letter. This is just the operations. Again, this is if you're going to develop a small-scale waterfront facility that's going to be fueling an LNG-fueled vessel. This is one of the, one of the actual policy letters that you use. It's not the be-all, end-all, and anyone that's developed a facility knows that. Harvey Gulf knows that. Tote knows that. That slide needs to be updated because Westpac has no longer involved in the project. It's just Clean Marine Energy and Oak Tree. So it's not a, it's not the type of thing where you go into lightly. And this is just one of the policy letters and one of the regulatory vehicles that they use in developing this. But again, Coast Guard's gone ahead and they've created it. I am not even going to begin to talk about this slide because I think we talked about NFPA 59A at length. That was sent for me from Jana at NFPA. They've been great to work with the moment the updates came out. 59A is a big part that people are asking us about when they call GTI about small-scale LNG training. So that's one of the things that I pulled from that slide. So that's actually an NFPA slide. Emergency response training. Again, this was a press release from GTI and the stakeholders. We had such good sponsorship from the first responders in Jacksonville, from Tote, from Crowley, Westpac. Everyone involved in this project was willing to pay so these firefighters and these sheriffs and these paramedics, they could come and take a half-day course. Part of the funding with that now, the Florida State College will have an LNG firefighting facility. There's only 2 in the United States. One's in Massachusetts and one is at Texas A&M. So again, as you build out this infrastructure for small-scale LNG, these are all greenfield applications. You're not going to have that many brownfields. This is breaking ground. So it's important to understand that you may or may not have a LNG trained first responder in your area. When I say first responder, it could be your emergency room. Do you have a cryogenic burn area within your ER or your local hospital? There's just so many pieces of the puzzle that as we worked with Tote and the various people in Jacksonville, as small scale spreads, you're going to need to understand who the players are. And that's kind of the one takeaway from this, from anything besides my horrible orange jacket. I do apologize. My son is graduating from the University of Virginia this weekend, and I had to rep the school, so I do apologize for that. But one of the things, the takeaway I would like you really to understand is that it's not a cookie cutter application for this. It's very important that small scale is not just one subject. It's so many different things, and it's very important that we get together and really, as stakeholders, everyone in this room, PHMSA will be a part of this small scale, but they will be different applications that they won't, the regulations will not fit everything. Again, what does GTI do? And the reason I'm just going to kind of go through this is because as we develop this small scale LNG, and I've only been with GTI for about a year and 4 months, so there's still people in the building that you probably know more about them than I do. But one of the things that we're seeing at GTI is that these small scale applications are affecting everyone along the value chain. So what GTI has tasked me with doing is really looking into training that's accessible, that people can afford, and people will understand, and you're not either over-educating or under-educating your stakeholder. Our approach really is, we're trying to do online training. For our first responders, TOTE has been very generous in underwriting an LNG awareness training that will be specific to LNG bunkering. That will be an online product that hopefully is going to come out later this month. For a first responder that's, he works a shift, he can't get to an ILT, what we call instructor-led course. He can't get there, so he needs to do something online. And this is one of the things that GTI has developed. We do a lot of, we do blended learning, but again, in the LNG space, we're seeing a need for really what they call butts in the seats, where you have to do your train the trainer, and for some of the people, online may or may not be enough. That's a TOTE shot that Lee Peterson sent to me. That's actually another bunkering shot of TOTE, of the Isabella. And one of the things that we've seen is that you really need to figure out what the level of education for that stakeholder is and what will their roles be. I had the unlucky task of training all of these security personnel, these longshoremen, the office workers a week after the El Faro tragedy. And I got to give the people from TOTE credit. They didn't want to be there, but they were very on board with LNG, and they knew they had to move forward, and they attended these training classes. And again, there was a real effort by the realm of stakeholder, the realm of responder, to really want to embrace LNG and small-scale LNG. So it was actually, it was a great experience for me in the fact that I got to see how invested Jacksonville, from the first responder to the woman that's a scheduler, were engaged in LNG as a fuel and are on board with the whole effort. Again, this is just what GTI does. We do more than the Mariner because, as you know, in the U.S., a lot of the union schools train their own. So what GTI has done is, in addition to offering Mariner training, we offer a range of options. And again, don't take the walk away as, gee, I looked at a GTI brochure. I want the takeaway should be that we need to understand all the stakeholders. And a lot of these stakeholders need to understand that the regulations are kind of in flux. And that's what we're running into as well, that people are not sure of what regulations apply to small-scale LNG. Again, this is just the offerings. You can see this on our website. We do 3-day small-scale LNG. And as we develop this small-scale LNG course, it too is, it really will go through a number of ruminations in the fact that we're really not sure what the perfect small-scale application for training someone will be. So that's kind of where GTI is. And that's just an example of what we train. Again, we have self-study. We've got quite an uptick in people calling us and saying, can I take your gas operator training? A lot of people are interested in that. I think as people see the small-scale LNG takes off, and the people are looking for operator information. So we're actually quite a few people are taking that class right now. So that's kind of what we offer online. And by the end of the month, you will be able to take a first responder course that will be addressed for the guy that's working as a paramedic or as as a fireman. And one of the things that we've found with that is they are very interested in that. So we've been talking to a number of states about that. That's about it for me. Thank you so much for listening to me. I know I took you away from coffee. If you have any questions, we can either do it at the end or right now. Thanks so much. The gentleman with a question.
Our next speaker is Kevin Ritz. Kevin Ritz is a senior engineering technical specialist with Baltimore Gas and Electric. He has 39 years with BGE in various roles within BGE's LNG and propane air peak shaving operations, gas maintenance organization, and gas control. Since 2008, he has administered the gas compliance program designed to aid BGE in complying with LNG, LPG, and pipeline safety regulatory requirements. Kevin is a member since 2000 and past chair of AGA's Supplemental Gas Committee, member since 2002, and current chair of NFPA 59, and a member of NFPA 59A since 2005. He has contributed to AGA publications, classification of locations for electrical installations in gas utility areas, and purging practices and principles manual. He has presented the following papers: Propane Air Plants, Streamlining Operations Through Technology in 2004. Sub-X Vaporization, 40 Years of LNG Peak Shaving and Baseload Service in 2006. And Hazard Detection, Notification, and Response Systems in 2010. And let us give a warm welcome to Kevin Ritz. Thank you.
Good morning, everyone. Recognizing that I am also in front of lunch, so I'll try and hold the timeline here and get through this as reasonable as possible. It is a significant amount of information. With respect to the outline, I'm hoping to get through this as efficiently as I can. There will be a brief AGA overview and BGE overview. We've reached some milestones ourselves at BG&E that I'm very proud of and would like to share with you. The focus of the presentation is really to maintain the safety and operational capabilities of the LNG plant. Today's main focus is to kind of present one methodology or philosophy of managing an older LNG facility. And this has been spoken about a couple times this morning relative to the aging, the lifespan of these facilities. And so we're gonna provide everyone an overview of that at a very high level. This presentation, it's not necessarily new. It's kind of a repackaged. Mr. Richard Hoffman with Hoffman and Feige and I presented this back in 2007 at AGA, and Mr. Hoffman's also a 59A member and very involved in all aspects of the gas industry. So, Richard, thank you very much. Glad to see you're here. With respect to the AGA overview, AGA was founded in 1918, represents more than 200 local energy companies, and also represents 68 million residential, commercial, and industrial customers. With respect to the LNG business, AGA's Supplemental Gas Committee, and again, a number of our members are here today. Nice to see some friendly faces in the audience. Our committee is very active in the LNG industry. We have standards task forces established within there that's very engaged in the NFPA 59 process, 59 and 59A process. There are members of the SGC that serve on that technical committee. Myself, Mr. Brightwell, Mr. Wenzel in the audience, so there's a number of those here. With respect to BG&E, as mentioned, I've been with BG 39 years and very proud of that time that I've been able to spend with them. But we've reached a milestone even beyond my 39 years. Is we're the oldest gas utility in the nation. We're celebrating 200 years in the industry that began all the way back in 1816 with Rembrandt Peale. So we're very, very proud of that accomplishment. A couple statistics here. With us, we have 800 square miles of gas service territory. We have 650,000 customers, approximately 3,200 employees, and that's to cover the gas and electric portions of our business. We also manage over 7,100 miles of pipeline, and pretty significant effort, and we're real proud and plan to continue that long history. Before moving on to the main body of the presentation, I thought it would be appropriate to do a brief, I'll call it a brief overview of the LNG and why we're calling some of these managing older facilities that we had to go back in history slightly. The LNG industry isn't new. I mean, it's not a new technology by any far means or product, but in the mid-1960s it really surged. And particularly in supply of supplemental gas to local distribution companies. So there was a number of the peak shavers were built beginning in and around 1965, and that really continued through 1970. During that 1970 era, we also saw the development of the import terminals, where we saw the U.S. energy infrastructure look like it was going to really require a significant amount of gas if we were to continue to go on the consumption levels that we were anticipating. So we saw several import terminals constructed under that. And with those being constructed, some of the existing peak shavers really leveraged the product that was at these larger LNG import terminals, and that was transported around, and particularly more so in the Northeast, to supply product to the peak shavers. So, you know, we were leveraging each other's resources. That's kind of all changed, as we all know now, with the onset of the shale gas development, and it's presented a number of opportunities that are going to be spoke to today, but there's also a number of challenges that are associated with that, with growing of the industry and how to cover that through regulations and keep our products safe. Shale gas boom in the U.S. is tremendous. We've seen a number, if not many, of the existing import terminals have now filed for development of exportation of our product, and successfully with Cheniere most recently with their first export. So congratulations. LNG is also being leveraged to support gas transmission MAOP testing. I cover both the LNG side of the regulations and also assist in our gas compliance program for transmission pipelines and our distribution system. So we are seeing significant levels of LNG being used in support of pipeline testing to keep customers from outages. And I would say at that point, while that's being developed and utilized, there's also been changes in 59 that we've had have been implemented to address some of any of the safety concerns related to the portable LNG facilities. Just a little bit more on the background. Certainly we're also looking at the alternative fuel, and that's going to be discussed and has been a number of times, so I'm not going to go in real deep there, but just some statistics, and this may vary depending upon where we were pulling our information. When I took the statistics here, we had 123 LNG facilities. I think Mr. Mayberry had mentioned maybe about 115, but the ratio of that, as you can see, are primarily peak shaving, satellite, which are the smaller facilities, as well as the base load terminals, which are now import and export. The average age, which I think is getting to the main point here, is about 1980 is the average age of those 123. the oldest of them being 1965 and the newest in 2007 that I'm aware of. Also, as mentioned, all the jurisdictional LNG facilities are required by the regulations to comply with reporting requirements in 191, drug and alcohol testing in Part 199, and the Part 193 LNG safety requirements. Part 193, as mentioned, also incorporates a number of other standards, and they're listed there. I'll point out some of the more significant ones are the API 620, which is the construction of the large low-pressure LNG tanks, ASME Bull or Pressure Vessel Code, which there's a significant amount of pressure vessels in the facilities, and probably closer to the body of work that I get engaged with is the NFPA 59, and currently it's the 2001 edition, with a small parcel being out there in the 2006 edition for the seismic criteria for the storage tanks. And if that wasn't enough, 59A in itself incorporates by reference a significant amount of other standards. And not necessarily all of these apply, but if, as an owner or operator, if you employ any of these fire protection systems that I've just called out here on the slide, you're required to comply with those regulations or those standards as if that was written specifically in Part 193. I mean, it just all links together. So there's a lot of expectations and a lot of hard work that goes into managing the facilities and keeping it safe. You'll also note that because it's the 2001 edition of 59A, you'll note that a lot of the incorporated by reference listed here are 2001 or even earlier editions. And I'll speak to that a little bit more with challenging the challenges that we deal with as an operator and member companies within AGA in managing facilities under these older standards. There are also about 20 more that I only had so many minutes and so many slides to get through. But the point really here is we manage a lot of standards, and there's very high expectations for those. So I hope that's a takeaway from this. To kind of set a baseline, we have to find some common ground and accept some facts or a starting place, because the facts sometimes can be debated. But I would say that, the LNG facilities that are in service have been properly engineered, designed, and constructed in compliance with the regulations. They've been inspected and cited during all that. They've been properly operated. The inspections have all been performed, and primarily preventative and maintenance is being conducted, which demonstrates that we're not seeing a high failure rate or downtime of the facilities, and that all the personnel are properly trained. Part of managing an older facility, or any facility for that matter, I mean, and I didn't cover the title of this, but it really is managing beyond the regulations, and the challenges is part of the title of this presentation. And part of that is appropriately managing the facility through its phases outside of what the constructive regulations call for. And the aging assets are process equipment, components, if not managed properly, can lead to decreased reliability, efficiency, energy consumption. So there's a lot of factors that weigh in. Ultimately, it's the safety of the facility that we're trying to manage first, but there are other requirements and expectations as well. Addressing aging requires maintaining existing equipment operationally while performing all the mandatory prescriptive requirements that are there. It also has to identify techniques to identify opportunities to extend the equipment life. There's also plans, long-term plans for that matter, for replacement of the components. And this is where the successes can come in, because these typically aren't shelf items that are in our facilities, and to keep the facility safe, modern, and serviceable and reliable, we have to keep up with upgrades throughout its life cycle. Some techniques used to manage older facilities or asset management. Maintenance management, we have to deal with that now as part of the regulations. We have to demonstrate that we're doing appropriate levels of maintenance. There's also the risk management aspects of that, the risk assessments that we might perform, the inspection and the data review, the prioritization, the development of plans to modernize your facility, and then actual execution of the plan. With respect to asset management, it really is just a system. It's a process that you can employ. There's a number of different ones out there. This is a really text-intense slide, so I'll leave you to follow up on this. But there are other standards out there that can be leveraged to develop a appropriate or thorough asset management process, and that's the ISO 55000 standard, which replaced the past 55, which some may be familiar with. I'll also like to mention, we have the API RP 1173, and while that's principally aimed towards the pipeline side of the energy business, I think there's opportunities there to leverage that standard, that recommended practice, and that kind of gets into the management's practice and support and understanding and managing and funding the operations and the upgrades to keep the facilities modern. So I think there's an opportunity there that many companies I know are interested in leveraging. With respect to maintenance management, and again, this is real high level, there's basically the three approaches. We have the preventative, the predictive, and the corrective. Each one of those can be more efficient than the other, more appropriate. Certainly the corrective is a more reactive. We would all probably agree that we want to avoid those situations as best we can, and that's through effective preventative and predictive maintenance. There's, I don't want to call it an industry standard, but a good goal to achieve is about 80% preventative, predictive, and about 20% corrective. If you can't achieve those values, you should be looking at your preventative and predictive actions to see if they can't be adjusted to get back to a more appropriate ratio there. Records, whether it be for regulatory requirement or decision making in updating facilities, is vital. If you don't have the record, you don't have the history, you might not only be out of compliance with the regulatory mandatory requirements for record keeping, but you might not have all the factors that might be involved in making a decision to replace or major repair to a piece of equipment. Risk management, again, has been talked about a number of times here today. I think this probably would align with those. It's a combination of probability and severity of an event. Risk management's the identification, assessment, prioritization of those risks. I would say, too, that the regulations are intended and were originally conceptually developed to address those risks and do so, I think, pretty well. But yet there's always room for improvement as we move forward and through lessons learned. There's other risks, and that's the perceptions, and we spoke of this earlier as well, the perceptions of the public and how they think we're adequately and appropriately addressing safety and maintaining and operating our facilities. Risk isn't constant. It changes with time. There's constant reevaluation of the risks that go on when you're managing a plant effectively. The preparation and execution of an action plan to address the current potential future risk is essential. Risk assessment, a little bit further of a drill down, to identify the facilities and components that present the greatest risk, downtime, production, decreases in efficiency, and or failure. And a failure doesn't necessarily mean it's a leak in a pipe. It's a failure of a component that puts that plant in an inoperable mode when you can't produce gas to put in a pipeline that you're serving potentially for us 650,000 customers. We don't want outages. When they're in the middle of the winter, that's a safety risk to them. We want to have that reliability. Reliability necessarily isn't directly linked in the standards, but it's an expectation of the existing regulatory confines. So one way to address that here, and these are just examples of facility examples, are storage, vaporization, transfer systems, liquefaction, and fire and safety. Fire and safety, that's one of your primary preventative and mitigating measures in keeping the facility safe. So you want to identify those systems, factors to consider. What components, assemblies store the largest volumes of product? Of those systems, what's operating at the highest pressures or flow rates? How frequently is the facility started up and shut down? You know, when you look at analysis of incidents, a lot of times it's during those phases of startup that incidents, things are going through cool downs and actions have to be taken and observations and inspections have to be performed. Use inspections appropriate for those components so that you can maximize and identify any degradation in that system. Determine potential impacts of failure, and the risk assessment results can then be used along with other factors in repair and or replacement decisions. Inspection and data review, and all this is an ongoing process, and I'm not sure if I have it in here, but AGA has, and the Supplemental Gas Committee has a project to update our preventative maintenance document for LNG, which will also include ways in managing. So a lot of the elements of what we're talking about here, we're hoping to have in that document once it's finalized. I don't really have a timeline for it. It usually takes a couple years to get that through committee, but it is actively being considered and worked on. Inspection of data and data review, development inventory of all components and equipment used in the various facilities. Identify how components age, deteriorate, fail. Utilize appropriate inspection guidelines. And a lot of these inspection guidelines aren't talked about in the code, so it's up to the operators. It may actually be in later editions of 59A in the annex, because some of these inspections aren't necessarily regulatory. So as Jay Jablonski, the chair of 59A, mentioned, we've advanced that by referencing some standards out there that helps operators develop processes and procedures and plans to perform appropriate inspections to help manage the facilities. You need to compare the data. What was it originally? How has it changed over the years? And then analyze thoroughly to determine what the remaining life in that equipment might be. Equipment and component list is an example, and this is just for one type of facility, a liquefaction facility. Things you would be concerned with certainly are the piping, but there's a lot of variations to the piping. Is it buried? Is it above ground? Is it hot? Is it cold? Is it insulated? All these factors might lead you to different inspection protocols or considerations when you're looking for corrosion and addressing corrosion control. There's a number of pressure vessels involved in these systems, the pretreatment systems, the compression. There was a lot of talk from one of the inspectors about all the compression that was at one of the facilities. You know, all these are long lead time items. The drivers, the motors and engines for these equipment, heat exchangers, cold boxes where the actual phase change takes place. Again, some of these are 16 months to 2 years out for replacement, so you really need to closely monitor that. And it goes on with safety systems, electrical systems, and ancillary equipment. And I'll say that that's just as important as the rest of the facility. It kind of gets thrown down in that small bucket of ancillary, but the plant doesn't run without a good air system, cooling systems, and so forth. So it's all essential equipment. How components age and deteriorate. To do that, and this is kind of the overview, I'll drill down a little bit in the further slides. We'll develop a list of potential aging, deterioration, and failure factors. We'll assign a risk value to that. And this is the subjective risk value that an operator might develop. And I'll walk us through some of that, I hope, to make that a little bit clearer. And then you really have to, again, determine what tools might be used on that equipment and to determine its condition. This is by all means not an all-inclusive list, but certainly corrosion is a high priority is in managing facilities, and corrosion rates are different at different facilities, and based on where they're sited can also be affected. There's also fatigue. That's more related to in many cases, mechanical equipment as it's operating. It may be overloaded, or it just may be fatigued beyond its expectations. So you have to be monitoring that, and there's ways to manage that. Things wear out. There's soft goods, there's valve components that are operating millions of times a year that just wear, and that's all mainly covered through normal maintenance that's more or less required by the mandatory regulatory requirements. Overpressurizations, are we managing that? Certainly that places stresses upon the equipment and vessels that we don't want to exceed, and managing that is good safety relief valves, good operating procedures, and safeguards in your control systems to prevent that. And then there's obsolescence. Significant amount of what we deal with is obsolescence, but I would say that most of the obsolescence is more aimed towards maybe the instrumentation, the electrical systems, than there is major process equipment. But there's a lot of major manufacturers and equipment that was installed at a 1970 plant that they're not in business anymore. They've been either bought out, or there's after non-OEM groups that help maintain parts and service for that equipment. As mentioned, there are some contributing factors to aging: the time, the age, the operating hours on the equipment. A lot of the peak shavers, some operate more than others. It's where you're at, how your distribution and transmission system is operated as to how much that plant might vaporize. If you vaporize more in the winter, you're going to be liquefying more in the summer. So you're wearing out both sets of equipment. So you may see increases in there. So you want to keep an eye on that. There's atmospheric conditions that are impacted with rain, humidity, water accumulations, contaminants within the air, particularly if you're sited near or in locale of major thoroughfares. There's air contaminants that promote corrosion. Certainly if you're on the shoreline or along the waterways, there's salt water that might accelerate corrosion. And then there's certainly extreme temperatures. There's operating conditions, again, with a number of startups and shutdowns. The number of times the equipment has been removed and returned to service. Pressure and or temperature cycles all add to the aging. And then there's a gas composition and insufficient maintenance. There's a number of different techniques that can be used on the inspections. I'm coming close to the end here, so I want to try and cover as much as I can. I'll leave this to you to look at, but these are just the possible opportunities there for the inspections. Talked about the review of the plant equipment. We're looking for changes in efficiency, for downtime, for failures, and that might be our primary focus, is to address them initially. There's a prioritization process that can be employed, and that's based on that list of the equipment in the operating facility. And along with that is the ranking of that prioritization of all those pieces of equipment. And it's going to capture, are PMs assigned? Do you maintain spare parts? Are spare parts still available? And the list just goes on and on. And again, this is not an all-inclusive list, but just some jogging thoughts here that might generate some additional questions here as you go through. The prioritization, after all that's compiled, is you apply your ranking system, you rationalize the results. Is it what you expected? Did you have the right ranking and the numbering system to make it work? Develop short-term and long-term mitigation plans that might include that list there, which is also preparing specifications for replacement. As for our engagements in the standards updating process, AGA, as I mentioned, has been really involved in this. There's AGA members with the Supplemental Gas Committee that serve. Jay Jablonski, I believe, addressed the NFPA process, and it is a balanced process, and not any one group can take control of the team. We've already spoken a number of times about the timeline for the regulations and what's incorporated. We have a 2001 edition currently, but there are multiple editions that have been published since then, each one being different levels of enhancement. Some of the challenges managing under outdated regulations and consensus standards. You know, the enforceable edition incorporates by reference a lot of the standards which themselves are outdated. Some enforceable editions also incorporate reference other standards which really aren't even no longer active. If you go to a newer edition and look for it, you won't find it. It's been superseded or replaced by another edition. Just a couple quick examples of this are the safety factors for pressure vessels has been spoken about. LNG storage tanks, the whole coverage for construction, design, and engineering has been repackaged. 620 doesn't cover it all any longer in the new edition. It's a series that all has to be employed under API 625, 620, and ACI 376 now. And then a lot of NFPA standards for managing fire protection systems. I'm not even going to attempt to go through this. I will say, though, that Jay covered a lot of these, and this is a breakdown of just what I thought was relative to that, and I've already mentioned about the annex material. So in summary, properly maintained, an LNG plant can be expected to have an excellent extended operational life. Obsolescence must be monitored, and an effective plant maintenance and replacement program can only be beneficial. Aging issues will continue to demand attention and action. LNG industry has an exemplary safety record. I'm proud of it. I believe all my members with AGA, the Supplemental Gas Committee, would support that statement. The record is to the credit of the industry, the standards, the quality operation, the people that are operating the facilities, all the stakeholders, the public included, with the involvement we have. There are our emergency responders. We can't do it without their support. We try and support them as we go through the process. And final here is the incorporation by later editions of 59A and also 459 as well are significantly outdated. And I think updating those to more recent editions will help the industry. It'll help the regulators enforce a more appropriate and timely set of challenges. However, without updating to the later editions, the body of work that AGA is committed to and all the other technical committee members really is mute if we don't apply that body of work and what the lessons learned we've learned over the last 10 to 15 years. And with that, I thank you for your attention, and if there's time for questions.
Questions?
Our next guest speaker is Pat Outram. Pat Outram is Vice President of Government and Regulatory Affairs at Cheniere Energy, a company engaged in liquefied natural gas-related businesses. She is responsible for all regulatory and compliance activities during the permitting, construction, and operation of the company's LNG terminals and natural gas pipelines. This has included 4 import terminals, 2 constructed, 2 export terminals, and 2 interstate pipelines. She leads the HSSE department with oversight of procedure development, training, compliance monitoring, and reporting. Under her direction, the Government and Regulatory Affairs Department successfully obtained all necessary licenses and permits for the first LNG import terminal built in the United States in over 40 years, and the first ever LNG export terminal in the lower 48 states. Prior to joining Cheniere, Pat was a consultant for several of the LNG peak shaving plants in the United States on LNG fueled vehicle projects and refueling stations, and code development for NFPA 57, NFPA 59A, and CSA Z276. Let us give a warm welcome to Pat Outram.
Well, good morning, and I know I'm sitting between you guys and lunch. So I will try to do this quickly. PowerPoint presentation up first, or are you going to show the video first? Doesn't matter to me. Video? Okay. That's a hard one to follow, but we'll do the video first. This video was at our opening ceremony, so it kind of gives a background of the LNG import terminal and the export terminal that Cheniere has developed. So we'll watch this first.
Natural gas demand continues to grow as nations seek access to abundant, reliable, and more environmentally friendly energy sources to meet increases in energy demand. The energy market is relying more and more on LNG to support this growth as demand continues to be driven by fuel displacement and incremental power generation needs. As a result of the shale revolution, the U.S. has an abundance of natural gas, far outpacing our domestic needs. LNG export terminals provide U.S. natural gas producers with an additional outlet for their supply. This opening up of new markets for the U.S. should reduce price volatility, increase market stability, and support continued energy investments in the U.S. Today, we are celebrating the opening of a virtual pipeline that is providing global access to U.S. natural gas. And it all started right here where you sit today. In February, we exported the first domestically produced LNG from the lower 48 in over 50 years. Let's take a step back and take a look at the journey. How did we achieve this? It all began in 2002. The market forecasted a natural gas shortfall in the U.S. This led us to take action and build an LNG import terminal. Our dedicated employees worked together to build a partnership with the Cameron Parish community, local, state, and federal government agencies, and our world-class contractors. After receiving approval, we began construction in 2004. This collaboration allowed us to build a state-of-the-art regasification facility that opened in 2008. The grand opening of our regas facility coincided with dramatic advances in drilling technology that opened vast reserves of shale gas from domestic sources. We saw this change in the market as an opportunity rather than an obstacle, and made the bold decision to pursue the development of an LNG export facility. This began our path to revolutionize the global energy market. This move was initially met with skepticism, but we forged ahead and were first in line to receive authorization from the FERC and DOE to be able to export domestic LNG, giving us first mover advantage by over 2 years. Because we not only survived but have thrived through this journey of change, we now have a facility which gives us a flexible platform for continued success. Our employees have stood by us through this challenging journey. Our customers and stakeholders have shown remarkable confidence and commitment. Our investors not only brought capital, but enthusiasm and support so that the project would be successful. The local community leaders have enabled us to make a positive impact, both for the local economy and environment. Without the support of the local, state, and federal government, our project would not have made it off the drawing board. U.S. LNG will forever impact the global energy markets and provides many benefits: energy security, supply diversity, flexibility, and further market liquidity. The facility you see today was possible because you supported our vision. The first export of domestically produced LNG would not have happened without your effort and commitment. Let's take a look at the historical moment when the first cargo with domestically produced LNG from the lower 48 was exported right here on February 24th. Thank you for joining us on this journey.
Well, that's a hard one to start after here, but I appreciate the opportunity to talk to you all today about the evolution of LNG trade and facilities around the world, and we have come a long way in the United States. U.S. LNG exports, you just saw Cheniere's LNG facility in Sabine Pass in Cameron Parish, Louisiana, and Cheniere's experience with standards and regulations. I would say to you that LNG is heavily regulated. It's one of the most heavily regulated industries in the United States. Multiple agencies. Robert's presentation actually gave you some insight into the detail of oversight that's being done on LNG facilities around the United States. We're focusing on facilities and regulations and standards, but really we're talking about people. Many people here have spent their entire careers making sure that LNG facilities are designed, constructed, and operated in a safe manner. And the fact that you have as many people that responded to this request really shows that. This industry is an industry that takes safety very seriously. And the results really speak for themselves. With 50 years of exemplary operations, very few incidences, and as Sarah had suggested, this actually makes a risk-based approach fairly difficult to execute on because you can't have a probability of zero, but that's what the facts represent. Regulators do a very good job. You have FERC, PHMSA, U.S. Coast Guard, multiple agencies, overlapping responsibilities, but they do a good job with limited resources. So PHMSA has had a similar overview of the LNG facilities. LNG is not a new industry. It's a mature industry. This timeline kind of gives you the outline of that, and others have spoken to that timeline. But the LNG industry has entered kind of a new era on the large side and on the small side in the United States. So let's look back a little bit. So you have the 113 peak shaving plants in the United States, and this evolution will kind of give you an idea of where I'm going with my presentation. So These facilities produce tens of thousands to hundreds of thousands of gallons per day of LNG. They're built in 1965 to 2008. They cost $100 million. Footprint of tens of acres, regas capacity, hundreds of millions of cubic feet, 1 to 2 storage tanks, 1 to 2 billion cubic feet of storage. That was the largest piece of the LNG industry history in the United States. More recently, though, you've had a step change to onshore regasification. So in the early 2000s, we started building import terminals. This is a step change. These are $1 to $2 billion facilities, footprints of hundreds of acres, regas capacity of billions of cubic feet, and multiple storage tanks. So again, a step change in complexity. And now you've got the export facilities. Those that are highlighted in white are under construction, and the blue are under analysis by FERC and other agencies. So this, again, is much more complex, much different era in the LNG facilities. Costs are tens of billions of dollars for these facilities. Footprints on hundreds of acres, approaching thousands of acres most of the time. Liquefaction capacity, you're looking at 1,000 gallons a minute, 7 million gallons a day at the Sabine facility, 5,000 gallons a minute. Storage, multiple tanks. So you have a ramp up here of the export capability out of the United States. So you see that we're going up to 65 million tons per annum, probably in the 2020 timeframe. So these facilities are under construction and are progressing well. As a matter of fact, the United States will be one of the top 3 manufacturers of LNG in the world by 2020. So you have Australia, Qataris, and ourselves. Geopolitically, this is a huge step change in the world in the LNG market. This puts it into perspective. Picture's worth 1,000 words. So the small square that you see kind of in the top center of the is an LNG peak shaving facility overlaid on the footprint of the Sabine Pass LNG export facility in Cameron. So you see that, again, this increase in footprint is really reflective of the increase in complexity. Now, the LNG trade has also really gone through a lot of evolution as well. In 1988, it was a very small trade, really Asian markets to the Asian suppliers to the Asian buyers, and then North Africa to Europe. Very small. Okay, by 2007, you see some additional complexity there, additional trading partners. Contracts are still based on oil indexation, really still whole process integration across the value chain there. And each source really went to a specific supply with no destination flexibility. 2013, you see a very much different picture here. Lots more players, still largely take-or-pay contracts, but the contracts have evolved now to hub-based pricing. You're seeing distinction, destination flexibility, and some other pieces. So you're seeing a huge evolution, not only in the facilities and facility design, but also in the complexity of the business model itself. So let's go specifically to Cheniere. You've seen the Sabine Pass facility. We also have a facility in Corpus Christi that's being built. Ultimately, 31.5 million tons per annum in the Cheniere facilities across 7 trains. 87% of that is contracted on a long-term 20-year basis. $30 billion of capital spend. So this is a dense slide, but Cheniere statistics. The LNG tanks that we have on site are 160,000 cubic meters. They're roughly the size of the Astrodome. You can put a 737 inside these LNG tanks. There are 6 trains at Sabine equivalent to 27 million tons. Each train measures 1,300 feet in length, so they're 3 football fields. There are over 30 gas turbines in the 5 trains at Sabine. You have hundreds of thousands of cubic yards of concrete, thousands of tons of structural steel, hundreds of miles of pipe, thousands of miles of electrical cable. Between Sabine and Corpus Christi, you have 950 permanent jobs, 150,000 indirect jobs. Cost at Sabine, $20 billion. Cost at Corpus, $10 billion. And you have our clients' 20-year contracts, and these are our clients. So you see Europe and Asia, you have both traders and utilities. Geopolitically, this has been a huge evolution in the LNG business. But we also have local impacts, positive impacts, $2.3 billion bought from 54 manufacturers in 17 states for the Sabine Pass facility. More specifically in Corpus Christi, our econometric study showed $2 billion of positive impacts in the area, in the region, during construction, and $700 million of positive impacts during the life of the facility. So Sabine, this shows you that the blue was the import terminal. That was a $1.5 billion facility. The orange is what's currently under construction, 5 LNG trains. 6 were permitted, and we are currently selling the 6th train. Again, we're a heavily regulated industry, oversight by multiple agencies, local, state, and federal. Some of that is overlapping jurisdiction. But we're not just regulators are overseeing these facilities. You also have multiple layers of review. You have our constructing contractor, Bechtel, who has a fleet of engineers, but you also have our engineers overviewing their engineers to assure that the facility is designed and constructed safely. Externally, you have a fleet of engineers that looks at this facility as well. You have the lenders who want to make sure that as they lend us money that they're getting value for their money. Customers, again, they have to have assurance that we're going to be able to provide LNG to them, and the insurers. So these are very well-reviewed facilities. You saw the video. This is a picture of the construction of the LNG facility itself. So the 4 trains, 5 trains that are currently under construction. Train 1 is commissioned. Train 2 is in commissioning, so that will come online here shortly. Train 3, 4, and 5 are under construction. And this is the Corpus Christi facility. We have 2 trains, 2 tanks, and 1 berth under construction there. Another tank and another train and another berth is permitted. And then we have 2 trains and 1 tank that is in the permitting process. And this is a construction photo from that facility, earlier in construction than the Sabine facility. So you see the 2 LNG tanks in the foreground that are being constructed, and the LNG trains, train 1 and 2. So this is a little bit of a dense side. Let's go to the regulations and standards. Again, you've heard that there are 3 major standards that we work under: 49 CFR Part 193, 33 CFR Part 127 for the marine facilities, and NFPA 59A. There are a significant number of reference standards in those standards and regulations. So 49 CFR Part 193 shows 9 reference standards, and 59A shows 61 reference standards. That regulatory process and the standards are similar in that both allow for public comment. A little bit different in that the regulations publish in the Federal Register and ask for public comment. NFPA 59A, as you heard Jay say, you can comment on that for a whole year's period, and the committee will try to take a look at those comments and evaluate them and put them into the standard as available. But the big difference is that standards are updated usually on a set schedule, and that is important because it allows for the integration of best practices, technological advancements, and lessons learned. And so that standards process is very important. The regulations don't necessarily have an interval, and this workshop is really very important in that it's identifying that we need to have some update in the regulations. That delay in updating the regulations or the standards in the regulations really delays integration of improvements in process technology, and that actually can increase risk, and we don't want to have that happen. So the issues that we identified in working in the industry over the past 15 years with these standards is that these older versions of the standards in the can negatively impact all three areas, both design, construction, and operation, and it can cause delays and increased costs. The design issue, we've mentioned the 1992 version of ASME that's identified in the 2001 version of NFPA 59A. That really required us to provide some additional information to the regulators, and that caused some delays. And that's unfortunate because that version actually was in error. It should have been an older version identified in 59A. But we've worked through that with the regulators, and there is that opportunity to do that as variances are allowed to the prescriptive standards, but you have to provide justification for those variances. On this construction issue, regulations actually call out a less effective quality assurance testing method. And again, we've provided information and gotten a variation from that. On operational issues, the regulations require prescriptive testing intervals for certain equipment instead of industry best practice or manufacturing recommendations. These prescriptive requirements actually increase risk and diminish safety, in that if it ain't broke, you don't want to go in and fix it in these particular instances. But, and the other thing that we're seeing is that the number of pieces of equipment that will need to be tested, especially in these world-scale liquefaction facilities, compared to peak shavers is going to be exponentially larger, we believe onerous and potentially unmanageable. So here are my conclusions. The LNG industry has evolved both in the United States and worldwide, and a very much smaller industry at one point, but now it's becoming, with the larger facilities, larger and a more complex business model. The regulations, now, although they're dated, they have served the industry very well. We have a 50-year safety record that shows very few instances in the United States. The U.S. regulations, however, don't reflect industry best practice in certain instances and actually increase risk in the design, construction, and the operation stage of the facilities. We believe a good first step is to update with the most current standards and regulations. And this shouldn't be controversial, should be able to be done quickly. The committees have done a lot of work to make sure that those standards are in good shape and reflect industry best practices. Ultimately, we believe that LNG regulation should reflect industry best practice and a risk-based approach. OSHA PSM is one regulation that's been out there since 1990. We feel like that is a good example. It's been vetted by quite a few years of use in other industries, specifically refineries in the United States. And we believe OSHA PSM is a good option for a path forward. Those are my remarks. Thank you very much.
Does anybody have any questions for Pat?
Well, thank you, Pat. At this time, we're going to take a lunch break. Julie, hour and 15 minutes. Is that the plan? And we have, I guess, two options basically for lunch. You can go outside and have lunch locally. There's a few sandwich places and whatnot outside. You'll have to give up your badge when you leave and then come through security when you come back. Do that thing this morning again. Or well, we have a cafeteria in the other building, in the east building. What we do is assemble in the back here next to the glass doors, and we will have escorts to move you over to the cafeteria in the east building. I understand that the personnel over there have made some extra lunches and whatnot for us. They're ready for us. Or you can, I guess the third option would be to stay here if you're not interested in lunch. But let's break, hour and 15 minutes. And if anybody from PHMSA can help you, just please ask.
can't see us, but we're here at the heart of this giant LNG carrier. At the heart of it.